Well, what's up, everybody? We are going to try and do something slightly different today. I'm going to give it a few minutes for people to join and for Aaron to get done with a meeting so that we can jump on and we can kuber some netties. And I think I have a cluster running. I was like, I just set this up last night so that we'd have a cluster to play with if we want to demo some stuff based on questions and stuff that we receive. All right. What do we want to do? I have Excalidraw open, so we can do that. Did I install K9S? I think I did. Okay, cool. Okay. Copperbeardy, thanks so much for the sub, man. Appreciate that. We're just kind of hanging out for a couple of minutes. I want to give everybody an opportunity to join. Things are really good. Been making some progress on the RTMP switcher that we're working on. Now, Aaron and I are going to do kind of an AMA. Both of us have been, he's been doing some cloud native stuff in his channel. And we've been doing some Docker stuff in mine just for our project. And lots of questions have been coming up. So we decided to just combine forces and do like we're just going to roll with it today. let everybody bring their questions, and we're going to go whatever direction it takes us, whether that's diagramming stuff or containerizing things or reviewing people's Docker files and making suggestions. How are things going? How's the stream been? Yeah, this container is actually pretty interesting because we were doing GPU stuff in it. Had the week off, bad cold. I was sorry to hear that. That's always it's always bad. I feel like whenever I take like a week off, it takes me a little bit to ramp up. It's almost like starting over. That like slight bit of nerves. Like, do I remember how to do this? I think, didn't Mastermind did a segment on containers too, right? It was like a 5 or 6 part series, I think. Well, I hope you're feeling better now. I still need to figure this out. Oh, I should be back Monday. Cool. What have you been working on? I don't think I've caught your stream recently. What are you working on now? You know what we should do too is pull people into Discord too. I think that would be kind of fun. Get some people in Discord and chatting with us and asking questions. I don't know that we're going to need these shells. I'm going to leave these terminals open for now. Just waiting for Mr. Aaron Schlesinger. All right, while we wait for Aaron, does anybody have questions? Let's get some in a doc. Let's get like a doc started here with like questions. I'm going to stuff it in downloads so that I remember to find it and remove it later. Container.
Hey.
Questions. Hey, there you are. All right, let's get you on screen.
All right.
Everybody was begging me not to bring you on. I don't know what the deal was. Apparently,
I get that.
Yeah, apparently you annoyed some people.
I get that sometimes. I annoyed everybody.
Let me see. Do I have you twice in here? I kind of hear like a slight echo for you. I do. All right. Talk again.
Hello. Test 1, 2.
There we go. The echo is gone.
Sweet.
I can only tolerate one of you.
Yeah, I get that. I get that sometimes too. One is generous.
Been doing Blazor WASM memory game. Oh, that's really cool. When does it make sense to? So Codephobia's got our first question. I was going to start creating a doc here of questions so that we make sure that we get everybody's questions.
Nice.
Maybe we'll organize these into containers in general and Kubernetes. Okay, so Codephobia's question is, when does it make sense to start using Kubernetes? Okay. So I used to tell people at conferences when they would ask me this question, if you can name all of the nodes in your system, you probably don't need Kubernetes, right? If you're like, we have DB1 and DB2 and Web1 and Web2, you're probably not at a scale for Kubernetes. The difficulty here is typically in very, very organic systems that are changing all of the time, right? Where you've got nodes being added and removed from the cluster, you're kind of scaling in and out and things like that. So that makes it harder to configure nodes as well as determining where things should go. I mean, the biggest issue with that is it's not that you can't use Kubernetes for smaller things. It's that it comes with cognitive overhead, right? Understanding how the cluster works, understanding how it fails, how to debug the cluster when it's not working properly. And if you're a small team and you're running on 2 or 3 DigitalOcean droplets, the amount of overhead in adopting all of that and learning how to manage the cluster becomes a lot more work for the team. What are your thoughts, Aaron?
I actually got asked this question on a podcast last week. So I'll repeat sort of that, but add a little bit because my thoughts have changed a little. So I agree pretty much 100% with what you said, Eric. But just to go a little bit in a different direction there, I think you should never start with Kubernetes just because of
Agreed. Yeah.
yeah, like not even necessarily about the nodes because that's very true, but let's say you get a bunch of free nodes and whatever, you're just going with it. You have an X number of people, probably under 2 or under 5 or whatever, and there's so much to learn just to get an app on Kubernetes on the internet that you're probably going to end up with more YAML than code at the outset.
Yeah.
So yeah. So it's not just app size, but I think it's number of people in your team size as well.
Yeah, I don't think I've ever been on a team where we've had Kubernetes in production where there wasn't a dedicated number of people who were just Kubernetes administrators.
Yeah, right.
So if you are a company that is large enough that you can support, pushing over 1 or 2 or 5 people, depending on the size of your clusters, to just manage Kubernetes clusters, then I think when you have a Kubernetes problem, Kubernetes is totally worth the investment to learn and manage. It's significantly less work than doing all of this stuff on your own.
Yes.
But if you're adopting it just for like buzzword hype, you're gonna have a bad day.
Yes.
It's a lot to learn,
Yeah. Actually, code phobia. I'm gonna skip just really quick. Let's go back to that question. But code phobia, you just mentioned you use Fargate, and the logical step seems to be K8s. I think if you can identify exactly what you need in K8s, that might be a reason to go and use it. If you need, let's say you need cron jobs and you need ingress routing, something complex with host-based routing in ingress, that might be a reason. But I think you need to know concept-wise and just work-wise at the outset, just to get started. I think you need to know and have a plan for how to deal with that.
And the same
before
thing
you make the jump.
goes for like adding things to your cluster, right? Like when do I need a service mesh? Well, when you have a service mesh like problem, right, and you're struggling with these specific things that those are meant to solve, if you're like, okay, so what do we need? We need to modernize our stack, so we need containers, and we need Kubernetes, and we need Istio, and we need all of these things. Like, it's a lot, right? And there's, we used to tell our teams, like, you have like a bleeding edge budget, right? You can only spend so many points on new technologies because, it takes a while to learn all of that stuff. But yeah, so I actually have the opposite opinion on containers, right? So if we move this over and we said, when does it make sense to start using containers? My answer to that would be right now. I'm not saying everybody has to go to containers, but containers take a little bit of knowledge, but the benefits that you get from reproducible builds, and when we think about containers, they really solve a packaging and distribution problem, right? How do we package up our application with all of our dependencies? How do we get that app somewhere else? So it creates kind of a nice design where the systems pull from some repository. Agree or disagree, Aaron?
I'm trying to think. My initial reaction is like almost everyone should, because some people some people have like a Go binary or like a tiny little Python script that runs their site, and maybe they're like stamping out a droplet or like an AMI or something, or they're just like they've got a server, it's their pet as opposed to cattle, and they rsync a Python script up to it, and that's cool. Like going to containers would add quite a bit of machinery just to get the same app running.
And
But I would say, well, one last thing, just really quick, I would say if you're anywhere above that, like you've got to upload a Python script and a bunch of templates and images or something, like PNG images, not Docker images, then I'm on board with right now for sure.
yeah, and I think that it's also important to think about like migration strategies, CI/CD, things like that, where how do I migrate to somewhere else? It's actually a lot of work if you don't have a container. If you do have a container, you just Docker run this thing on the new node, right? And CI/CD, you often have these build machines that are configured to build specific applications, and then you end up in a scenario where different applications have different dependencies and things like that, and customizing those can be very, very difficult.
Yeah, for sure.
Another question, why is Kubelet so resource hungry? Okay.
We've got one from Oscolaron too about Docker versus Podman.
Where's that one? Oh, Docker versus Podman. Okay, here. We'll do a poll.
There you go. Yeah.
Wait. I swear it's poll. There we go. It didn't want to pop the menu for me. Okay. Docker versus Podman. Docker. Podman.
Nice.
Something else. CRI based. Okay. We'll run it for 10 minutes. Done. All right. Here we go. We're going to get the answer to your question. Okay. So the answer to the question for Kubelet, this would be actually interesting because I don't have a ton of experience with Docker Swarm aside from like playing with it. So I don't really have production experience with Docker Swarm. Do you, Aaron? I don't understand kind of internally how it works and how the control plane works the same way I do Kubernetes.
Yeah, I don't have much experience with it either.
I'm going to pull up a video of a talk I did that I know I have slides for, because I know that it has a slide that has kind of a diagram of what Kubelet does. There we go. So Kubelet itself is responsible for like a whole bunch of stuff. So it's basically sitting here communicating with the API server, looking for changes to pods or jobs that are associated with its own node name. But then once it does that, it's doing a bunch of work to go out to the registry and fetch the images. It cleans up old images and things like that. It's communicating over the container runtime interface to whatever your container runtime is to start those things. Also collecting logs and things like that. It's doing some performance things and shipping that up to the API server. Did I say it's setting up network yet? So it also uses CNI to set up the network stuff. So it's responsible for quite a bit of things. It's actually, that probably has the most logic in it in most of the cluster, right? I mean, API server is probably up there too. But Kubelet is what does actually the majority of the workload of what we think when we think about Kubernetes running things for us, right? Everything else is kind of like a declarative API that controllers are basically taking. Let's find one. That's operator. Give me a controller. Controller. There we go. So this is like the controller managed. Somewhere in here. Okay, so everything else is basically like a series of controllers where the API server is kind of like monitoring one set of resources, and then the controller manager is like on a long pole to the API server waiting for those changes, and then it will either update the same resource or create and modify and manage other resources. So these are actually pretty straightforward. They're just HTTP and kind of like reconciliation loops based on what changes it observes on the API server. They don't do a lot of work. The things that do a lot of work are the cloud controller manager, which communicates with your whatever cloud provider you're running your Kubernetes cluster in to, set up managed storage and hardware load balancers and VNets and whatever other stuff is built in.
Volumes.
Yeah, volumes. Kubelet, which we just talked about, does all of the work. And then I guess Kubeproxy, which is managing a bunch of IP tables. So much IP tables.
All of the IP. Another thing about Kubelet is if you've got 3 nodes and you're trying to run 50,000 containers or whatever it is, the workload on the kubelet is gonna scale linearly to the number of containers on the node. So, a kubelet sitting there doing nothing is pretty much just going to be talking to the API server, and the containers are going to do their thing, and that's pretty much it. It's responding to events. Exactly.
All of the metrics, all of the logs, it starts getting very, very chatty with the API server. And then you've got things like if other people are doing things. If you do a kube control exec, it is actually it's actually connecting to the API server. The API server connects to the kubelet, which then executes your command in the same namespace as your container and then ships all of the standard in and standard out back to API server and back to you.
It's a series of tubes.
Yeah.
Going all the way. But that's a connection. That's an open connection per person doing kubectl exec. And that can scale pretty high if you've got a big team.
Okay, so talk about microkates too. So microkates and it's escaping me. What's the other one?
Minikube.
Minikube, yeah.
Crap.
So those are all basically ways of their single binaries to run a, development cluster locally. So
K3D.
What's K3D?
Is there Kubernetes and Kind?
I remember
too,
K3S.
Right?
I remember that one. What about the master worker boundary here? I'm sure you don't put cloud administration controller and worker nodes. Yeah, you typically want to keep those separated. We should add that.
K3D is like Kind.
Separate control plane components from worker nodes. Yeah, and so there's a couple of reasons that you want to do this, right? And the reason is the entire cluster is basically a declarative API, a series of declarative APIs where there's a bunch of components that are just reconciling. They're just Kubernetes is just a crap ton of reconciliation loops, right? So the problem becomes like if I were to introduce some logic to a node and I saturate it, I could bump offline one of my control plane components, and we don't necessarily know what the side effects of that will be. And so, like, here's an example of weird things that happen when you don't think about those. I used to, when I would give workshops on Kubernetes, I would ask people, I'd teach everybody how to build a replica set and how to scale that out, right? And so we would deploy a pod, and we're like, okay, let's scale it to three replicas. Okay, how about 10 replicas? How about 1,000 replicas? And so what would happen is everybody would set the replica set to 1,000, and then all of a sudden their cluster would go offline. It's like, but what happened? But Kubernetes, right? Kubernetes is supposed to help me scale here. And that's the problem with like leaky abstractions, right? So inevitably what had happened was we intentionally did not supply CPU or memory constraints for the pods. So the scheduler has no idea how much CPU or memory this thing needs. So it happily schedules more of them. And it schedules them to the point where the node is so saturated that the kubelet can no longer communicate with the API server. So the API server is like, well, crap. this node is down. I need to reschedule all of its work, right? And it schedules it all to other nodes, which then make them saturated, which bump them offline, and so on and so forth until your entire cluster goes down. So
Yeah, thundering herd.
yeah, so it's important to try to think about those things, and not just in our own systems, but that's why it's so important to separate the control plane, right? So let's say that you have a horizontal pod scaler set up, you know, so you need more instances of something. It happily schedules them, except now you're starting to really, really slow down response time. Let's not even say that it's so saturated it's unresponsive. But what happens if etcd is running on those nodes?
Mm.
Now you can't get consensus, or not at least quickly, and then everything in the cluster starts behaving poorly.
Another thing I saw my last job was we did run the cloud controller on one of the worker nodes, and it got saturated, and the cloud controller started flapping. Crash gets restarted. Crash get restarted. So when new nodes would scale up, they would wait for a cloud controller. I think it was for volumes, so for persistent volume claims. So they'd wait for the cloud controller to get the volume. The cloud controller would not be able to provide it because it's going up and down. And so the number of nodes started building up because they're all waiting for cloud controller, which in turn makes the cloud controller go offline more often. And that's kind of another example of that thundering herd. Things make each other worse over time.
What do you mean, Kate's is not just a magic spell that I can use to automatically solve my scaling, just yelling microservices?
Microservice. Oh, Native, what's up?
Use my 4 musts: use namespace quotas and limits, enforce defaults, turn on and use RBAC, network policy, yep, pod security policies, yep. Those are all very good recommendations. And there's a few things that you can do too, right? Like there's such thing as like admission controllers, so that you can use, or what's known as a mutating admission controller, so that every time, so every time something's any Kubernetes resource is submitted to the API server, you can effectively have a webhook called, and then you can either like reject it or accept it based on things like it doesn't have CPU constraints in there, so we're going to reject it, right? Or you can just set defaults if you're using a mutating one.
Yeah, you can do kind of higher level policy stuff too. You can enforce naming, or you can make sure no one ever submits a service with a type load balancer. Something I've seen before too. So it forces people to use the ingress instead of the load balancer.
Begin, welcome. Thanks for the raid, man. So we are doing a Q&A on Docker and Kubernetes. Has anybody here used Docker or Kubered some Netties before?
I like how Doom came in. Set pink, my job is done.
That's Dr. Dumenberg's thing. He has to do pink.
Yeah. Andy Schneider, what's up again?
Can we touch on Helm? Okay, so let's add that. Helm. Aaron, I will let you take that because reasons. I wonder whether it should do an introduction or anything here. OPA, Open Policy Agent, is great. Yep. Never have I Dockered or Kubered the Netties. Okay. What is CNI and how that works? Okay, I can answer that one. I've done some custom CNI stuff. Actually, that same video I can pull that up. What is CNI and how does it work? Okay, so we're going to separate these, the ones we've answered already.
Xenus Zing. I love it. Take the helm on helm.
Rush, thanks for the follow. Galapis, thanks for the follow. Also, everybody be sure to follow Aaron's channel here too, who also streams on cloud native technologies. Okay, hit it with the helm.
With the helm. What was the question? Pros and cons?
I think it was just, can you touch on Helm? Like,
touch on Helm.
Yeah.
Okay. Yeah, I mean, Helm is great. If for those who don't know, Helm is closest to a package manager combined with a release log for Kubernetes apps. So it allows you to take all of your Kubernetes YAMLs and put it all together into one package that you can deploy as one thing, and also then allows you to parameterize those manifests as well. So you can change the name or update a tag for your Docker image. Those are common things that people do, but you can do anything.
Yeah, like if you wanted to run multiple instances of something, well, they need
Yep.
different names. And if you
Yep.
have all of these things, like, okay, well, it has a pod and it has a service and it has an ingress controller and it has all of these things, and I have a ton of YAML files or one giant YAML file, it allows you to like parameterize that. So you can say, hey, take this, but this one's going to be V2, right?
Yep. New namespace if you want a second thing. Blue green deployment if you want to do that. There's tons of possibilities, and it allows you to keep track of releases. So if you do a Helm upgrade, Helm will keep an append only log of the releases you do, and then you can roll back as well. So pros and cons, those are I would say those are the pros. The ability to parameterize and thus deploy multiple different kind of stamp out multiple different versions of your app, and then do rollbacks and track releases, a log of releases. The cons are it adds that next layer of complexity. That's the biggest thing for me.
Yeah.
You're getting started with Kubernetes. You got to learn all the concepts, at least the basics, how to write all the YAML. And then at that point, you got to learn kubectl. And then you're up to the point where like, hey, you can build your app and deploy it. But then you're going to have to layer on YAML Helm. You're going to have to layer on Helm. And that's when you start getting into how do I set up Helm? How do I set up the release log and blah, blah, blah.
All right. I'm going to touch on CNI, but this question like falls right into what you're talking about. So what is Deus Labs?
Yeah, I would. Yeah. Should I go now or do you want to do CNI?
Do it now. It fits right along with this because Helm came out of Deus, right?
Yeah. Yeah. So Deus was a company. I used to work for Deus. Deus built the first version of Helm, a PaaS on top of Kubernetes as well. A couple other tools as well. One is called Draft that still exists, but it's not developed too actively anymore. So Deus got acquired by Microsoft and came in, and we became we kind of call ourselves Deus Labs. There's a GitHub org called Deus Labs as well.
And when he says we, he doesn't mean the royal we. He means like Aaron actually came to Microsoft through Deus.
Yes. Yeah. So we called ourselves Deus Labs, and it's the group behind Deus Labs is responsible for building out high quality open source software for Kubernetes. And Eric worked on one of the things that Deus Labs worked on recently, which was WebAssembly on Kubernetes. They do stuff like that, and they'll continue to do kind of push the envelope for Kubernetes things, for open source Kubernetes things in the community. So Quinn Kwan, I'm just gonna call you Quinn. So Quinn, you'll see more cool stuff coming out of Deus Labs on GitHub because that's their mandate inside of Microsoft.
Yeah, and I mean now there's things like Porter and what are some of the other projects they're working on that are getting popular? CNAB, yep. And yeah, and I guess to be clear, right, like some of the projects will turn into like really awesome things and some of them will fall flat, right? Like most of what they're working on is so kind of experimental, like trying to jump 10 feet ahead of where the industry is and trying to figure that out. Like using Kubernetes as a scheduler for WASM is like some next level stuff, right?
Yeah.
Like
and that's like how long do you think, if that becomes a thing, how long do you think that would take?
Minimum of 6 months before probably people use anything like this in production, maybe a year before like it really takes. But I mean, there's a lot of reasons, and we could do another stream about this and maybe even bring on some of the folks that work on Crustlet. I help with some patches and things like that, but we could bring on some of the people who actually work on it if you're interested in some of this stuff.
Yeah, and Rust too. This is one of the few implementations of a Kubernetes thing in Rust.
Okay, so the next question was, what is CNI and how does it work? So I'll take that one because I've got some diagrams here from a talk I gave. So sometimes these things are easier to visualize. So we talked about kubelet and how it talks to the CRI, which is a container runtime interface. Like that's the component that talks to Docker. There's also now CSI, which is the container storage interface. That's a whole other thing. So CNI is the container network interface. And so what that actually is a series of 1 to 2 binaries. And what will happen is you'll configure in your CNI directory here a CNI plugin. And obviously you'll just give it a name. And then down here is a separate CNI plugin. So this one is responsible for kind of getting the interface into the container, what the interface is, configuring all of that. The IPAM module is responsible for managing the IP addresses associated with it. So there's a few plugins that exist to begin with, Bridge, IP VLAN, etc. And so the kubelet will call out to CNI through just executing shell commands and passing JSON to them. And then they're sort of responsible for doing their thing and returning back responses. So you can write your own CNI plugins. And in fact, in this talk, I talk about why we did that at Comcast, because we needed to do some software-defined networking so that we could actually move IP addresses around due to the fact that the thing running in the container needed to send multicast from the same IP address. Something downstream was using source-specific multicast. All right, are we caught up on questions?
We've got one on ingress.
Okay, we have ingress. Also, everybody here too. Well, I'm paused here. Finitely generated. Thanks for the follow. No question is a bad question. We are also happy to do a intro to Docker or K8s, right? I'm also happy to demonstrate how a container works internally. That can also be a very interesting topic as well. Okay, so ingress. You want to talk about ingress?
Yeah, I wanted to just shout out to Hello LM talking about draft. I put some suggestions on maybe a replacement for draft, but yes, it hasn't been actively developed for I think something like 6 months to a year. There's bug fixes still going in, but yeah, there's some replacements out there. So ingress routing, which do you prefer, Nginx, Envoy, Traffic, or something else? I went with Traffic for the longest time, but I found that Traffic is trying to do ingress-like things for lots of platforms, not just Kubernetes. So it's harder to get things done. Like it's harder to configure something in Traffic than it is in the Nginx ingress, just because Traffic requires some things you have to do in a config file rather than environment variables. And some things you have to look in the code to find out how to do it in Kubernetes rather than the Docker way or the whatever other way. So yes, I'm all about the Nginx ingress with Cert Manager for TLS certificates.
But can you live code a mini Docker like Liz Rice? I could live code one. I don't think I could do it like Liz Rice though. Liz is an amazing speaker.
Yeah, and super smart.
So I'm curious now that we kind of have a bigger group here. What's everybody's experience level in Docker and Kubernetes? Like, does anybody need like a crash course on what a container is, why you would use one, what Kubernetes is, how to actually create a Docker file? I'm happy to even get people on Discord or, show us your Docker file and we will try and fix it.
That'd be fun.
I know Docker, but would like to know more about Kubernetes. Okay, are CRDs the future?
I could take that one.
Yeah, go ahead. I have feels too, right?
Okay. So I have feels from the pain in the past I could talk about. Are they the future? I think so. So short answer, yes. My past is I worked on and with something called third-party resources, which was the predecessor to CRDs.
This whole talk is talking about what we did with TPRs before they were
Nice.
CRDs. Yeah.
Okay. Yeah. So TPRs were a thing. We built a massive system around them. You can still find it out there called Service Catalog. And they got deprecated, and there was a period of time between then and when CRDs became, the thing, when it was unclear whether there was going to be a replacement to TPRs or there was going to be something that still exists called admission controllers. At the time, they were called aggregated APIs. And those were kind of what the webhook thing is today. Kubernetes would reach out to a REST API on a standard interface, and then your implementation of that REST API would tell it what to do. So kind of like a callback. So then that was a thing that was going to be the future for, I think, 9 months or so. And then CRDs kind of won out because they are a bit simpler than the whole aggregated API concept. So all that being said, CRDs have stuck for a lot longer than TPRs or aggregated APIs. So I believe they're the future. They have tons of buy-in. Operator Framework uses them. Ingress uses something like them. And Ingress actually kind of established the pattern for CRDs. What else? The Nginx Ingress uses them. The Ingress object and CRDs. So yes, I think they're the future.
Yeah, I totally agree with that. And the reason I say, and I actually, the next question kind of ties into this with operator framework.
Yeah.
I have slides here where from that same talk from, no, I guess that one was 2018, but the TPR talk was 2016. But no,
nice.
I think CRDs, like 2 weeks, I did a keynote at KubeCon 2 weeks after they CoreOS announced the operator pattern.
Nice.
I was like, we think alike.
Was the operator pattern built on
TPRs? Yeah.
Originally?
Yeah.
Nice. Yeah.
So when we think about the way Kubernetes is designed, we went through some of those slides, right? Like, it's just a series of reconciliation loops and a declarative API for that. So it's a really, really good pattern. So this whole talk here is actually talking about using Kubernetes as a framework for building your own distributed systems. And I do another one where we actually talk about how we scheduled at Comcast, we scheduled live video, like cable video broadcast through using TPRs. And so I totally think that's the way to go, especially when we get into the operator pattern. Where are you? There we go. Oh, I actually walked through here too. So the operator pattern is used for introducing operational knowledge into your cluster. So we do things like this. So here's the Prometheus operator as an example. We're just declaring to the API server that, hey, I would like Prometheus running with 2 replicas, and this is the service account that it's going to use. And then that operator is responsible for managing, say, a stateful set to keep this thing running, but it understands that. So I could set the version here, right? And then update this resource in the API server, and then the Prometheus operator understands how to upgrade from version, 1 to 2 or whatever. So I think that's a really important pattern, and this scales even beyond that. So Prometheus operator, I love this one as an example because once that's installed in your cluster, you also get a custom resource type called a service monitor. So we can submit a service monitor to the API server, telling it that we want to scrape metrics for any services that match these selectors, and which ultimately internally maps a config map and modifies a config map inside of Prometheus. All of this stuff is an implementation detail we don't have to think about, but it's just what Prometheus is doing. So if we think about like a large enterprise environment or something like that, if you deployed a new application out to production and you wanted to get your main monitoring system to scrape the metrics from it, you would have to put in a support ticket with IT or something like that, and there's no telling how long you would have to wait for this. And then you sort of have like this crud that builds up where, IT and the developers are separated. So you take that application down, but now this config is still there. It gets kind of messy, right? But this is a really, really clean way for you to package with your application when you deploy it, the declared state of I would like the monitoring system to monitor my application.
Yeah, I think it extends the standard API and design pattern of Kubernetes. You mentioned declarative APIs, you mentioned reconciliation loops, and all the built-in Kubernetes APIs are that. So CRDs is just a way for someone to create their new API based on those concepts and give it a schema and give it admission controllers and all that good stuff.
Oh, and I also wanted to point out that Hello, I'm JVB here is actually from Rancher. So we've got some other container experts here in the house. Let's see. I'm trying to make sure I keep up with all this stuff. Many clusters or many. Okay, so here we go. So I want to address a question we had earlier about regular containers. So I have containers running locally. What's next? So you've got a couple of options here, right? So one would be that you just install Docker on your production machine or something like that, right? That would be like probably the most minimal next step. And you could expose that. Obviously, you have some security concerns, but you can set a Docker host locally so that you can just run Docker commands and deploy your Docker container on that host that exists elsewhere. Some other options would be using things like Fargate or ACI or what are some other ones? Help me out here, Aaron.
You got Cloud Run and App Engine, Flexible. I think the new DigitalOcean thing supports containers out of the box.
ECS, right? Well, Bartholomew, we're trying to, I wanted to avoid EKS and AKS because I think that, if you're not already in a world where you have Kubernetes-like problems, you probably want to start with like, okay, now how do I, rather than deploying my application, how do I just deploy my container in a similar way? Adopting Kubernetes is like a whole other, batch of knowledge that you need to get. If you work in a large scale distributed system, right, you've hundreds of nodes or thousands of nodes, then you probably want to get your team involved and probably go straight to Kubernetes, right?
JVB, I like it. Kubernetes problems.
So.
Oh, does Azure have equivalents of those?
Of what?
I assume you mean like Cloud Run and that kind of stuff? Bartholomew?
So the next question, which kind of ECS and AKS, it would be ACI, Azure Container Instances, would be equivalent to ECS as far as my understanding of ECS is, and then EKS we have Azure Kubernetes Service. Yeah, pretty much all of the cloud providers have these. DigitalOcean has a Kubernetes thing. IBM has one. Any cloud service that does not have a Kubernetes offering will probably in some time, right? There's only two types of cloud providers now: those who have a Kubernetes offering and those that will eventually have a Kubernetes offering.
Mm-hmm. Even Linode has one. They've held out for so long, but now they have LKS.
So, okay, next one, kind of like on the hype train thing, is a service mesh a necessity or an overrated hype? I have probably unpopular opinions on this one. I personally think that they are overrated. There's things that I absolutely love about service meshes like Istio, but there's things that I don't like. There's a lot of stuff baked in. There's a lot of features, and I really wish that you had the ability to kind of like ease into them. So again, this is kind of like my same opinion on Kubernetes, right? If you have an Istio-like problem, you know it, right? And then maybe that's the time to adopt a service mesh. But what I what I typically find is that people will be like, how do we get to a modern application architecture? We need to containerize everything. We need to do them in very small microservices. We need to run that on Kubernetes, and we need Istio. Like, well, why do you need Istio? Because we need Istio, right? And so it's just like anything with building your architecture out, that you're adopting more dependencies, you're adopting more places where things can fail, you're adopting more leaky abstractions where, here's my question to you, right? Like, if Istio, if the sidecar starts behaving and all of those things, and traffic's not routing properly and all of these things, do you know where to look? Do you know why it's failing? And the same thing can be said about Kubernetes, right? Like, how many people know how to debug DNS in Kubernetes, right? Like, how many people know how, when networking doesn't work, to know which component in the control plane is responsible for that, like where to look. So, it's all cognitive overhead where you need to learn it. And some people are in environments where it's less work to learn that and to have a team manage it than what they're already doing or what they're going to need to do. And in other environments, it's a whole lot to learn for very little benefit over what you're doing. And that can be said about adopting any technology. This isn't just a container adoption thing. This is, people are very, very quick to adopt some technology because it seems like everybody's using it. We need to migrate to that. I think Kelsey Hightower said it best when he said, legacy means you're making money, right?
Yeah, boring infrastructure, right?
Opinions on OpenShift.
Let me add one thing about Istio specifically. If you can't install Istio without knowing what's going on in each step, don't use Istio, because it's a beast just to install. And if you go through and you figure out what each step of the installation is doing, then it's probably going to be you're probably going to have a better time. Whether you should still use it in that case, I don't know. It depends on your business case, but I think you need to at least be able to install it responsibly in order to go ahead and start using it responsibly.
Yeah, I think Hello, I'm JVB said it best. OpenShift is great, but understand you're buying an opinionated K-based PaaS that's not 100% vanilla. Full disclosure, I work for a competitor. Yeah, and so I think today's conversation is, I think, completely open and honest, right? Like, I'm happy. I work for a company, same with Aaron, who has a Kate's offering, and both of us are perfectly okay with being honest about faults in our own offerings and other people's and what other people do better and all of that stuff. I think that's one of the really cool things about the DevRel team we work on.
I'll come out. I'll be honest about my favorite container offerings right now. DigitalOpen app platform it looks awesome. I haven't run production apps on it, but it looks slick, awesome, well documented, all of the stuff that you would come to expect from like a solid DigitalOcean product. So, check it out. Check it out. It's not an Azure product. I'm not getting paid by DigitalOcean, but I see the quality in a container. Yeah, there's the check is right here. I see the quality of a container native platform in it. So yeah.
Okay. Oh, wait. We missed this one. Opinions on OpenShift. OpenShift. What is OpenShift? Okay. Wait. Nope. We already did that. Oh, many clusters or namespaces. So, it depends, right? So what problem are you trying to solve, right? And so the biggest thing I see that people misuse namespaces for are using them as security boundaries. And we have to be very, very careful about that, right? Because these are not hard security boundaries. Neither is a container, right? Mm-hmm. If I pop the container, I am on a host with other containers. So I think it's important that we remember that whenever we're trying to design things around security. So you could, in theory, use the same cluster, right? you could in theory use the same cluster, and you could use things like taints and tolerances and node selectors to put things on nodes that are more secure or have TPMs in them or something like that. It's not 100%, right? Because in theory, I could also screw around. If I was able to pop the control plane and things like that, I could or even pop the container, I could in theory get the kubelet to run a static pod and things like that, and play around to try to get it to schedule work to my node and things like that. So you have to be very, very careful about that. I would personally say that if you have hard security boundaries between components in your system and things like that, they should probably be in separate clusters. If all you're doing is trying to organize things so that you're not looking at 100,000 pod specs inside of Kubernetes, and namespaces are the way to go. I'm happy to hear Hello, I'm JV's opinions on this too. gvisor is interesting there from a boundaries perspective, not used in production yet. Yeah, that's true too. There are some container runtimes that do offer more security boundaries in them. Why do you need?
I would add something about gvisor. It's used in production by the Go playground, not in Kubernetes, but they do use it to sandbox everyone's Go code that they run in the playground, for what it's worth.
Yeah, and there's some interesting projects too. Now I'm like, the names are escaping me. What's the Project Falco by Sysdig, which does a lot of profiling and things like that of syscalls to be able to understand what syscalls an application is making and that it's behaving separately, differently. Liz Rice's company, Aqua Security.
Yeah.
Tigera has one. There's a few people who are working on some of those, trying to solve those things. And again, like any kind of Linux security, we're trying to bolt all this stuff on after the fact, which gets kind of problematic, which is why you should probably try to separate these things out as best as you can.
Another reason you would want to go with multi-cluster is regions. If you want to have high availability and low latency for Southeast Asia and Western Europe, you need that. You can't just do multiple namespaces, obviously.
So Smallbrew asks, why do you need containers and not just a bunch of processes? We touched on this a little bit here earlier before everybody rated, but we're happy to go over it again. So if we're not talking about Windows containers, because Windows containers are just Hyper-V VMs, right? If we're talking about kind of Linux containers, I would argue they are the same thing because technically that's all they are. The host system sees them both as processes, right? So at the end of the day, a container is a zip file with the entire root directory of your application with all its dependencies that gets pulled down, extracted. Your process gets ch rooted into it, and then some controls are set for how much CPU and memory it can use and what things it can see, like what other processes can it see, what network things can it see. But as far as the Linux kernel is concerned, it is one. Doesn't a container have more load? It shouldn't.
Might take up a little bit more disk space.
Yeah, I mean, yeah,
memory.
Because at the end of the day, the namespaces and the C groups, every process on your system is already doing that. So we could look at ls/sys fs C group, right? So here's all of our C groups for everything on the cluster. Do I have anything running in here? Let's just do a docker run -it bin bash. Okay. Oh, it might help if I give a container name. So let's just do Ubuntu. All right, now we have an Ubuntu container running here. Let's see, what do we want to look at? All right, so inside this directory, we have all of the C groups that are Docker related. And up here, you can see a nice folder here. And that is, if we do a Docker PS here, we can see it coincides with this container ID. let's look at it really quick. So here's all of our stuff. So we've got CPU accounting and things like that. But if we looked at, say, like CPU shares, oops, I'm LSing it, cat. We can see all of the constraints that we set for these things, and we can do the same thing for memory and all of that good stuff. But I just wanted to point out that there's nothing special about any of this. Just the fact that they're in the Docker group, and then it's a subgroup of those. But everything on the system, right? You can see that systemd has its own. So yeah, as far as the host is concerned, right? What do we want to do in here? Do I have top in here? I don't need to sudo apt install htop. Give me something here.
You got to apt update probably.
Okay, so well, what I want to do here is we're gonna just do a ps aux grep top. So where are you? Top was the wrong thing to search for. Where are you?
There's one.
Yeah, oh, right here, right here.
One, yeah, root.
Right here. So this one here that's being run by root, this is actually top running in the container. So the host does not see this process any differently than it sees any other process on this system, except you'll see some differences, right? So like this PID does not coincide with if we did a Docker exec minus IT. Crap. What was our? Docker attach. Oh, here we go. 052. Oh, that's just gonna. Nope. That's. I want to exec it. All right.
I think you need IT.
I can't type today. Okay. So in this case, right? So if we did a PS here, we get a different PID inside of the container. And that's because these are it's in a different namespace. Now, here's the fun part, right? So we can actually cheat here. I'm going to have to scroll back up here, but I just want to demonstrate a couple of things so we can see what's happening. Like remove the magic of what a container is and sort of like the illusion of a container being like a virtual machine. So if I move to my host, well, actually, while we're in here, we don't have the IP command. I always forget what package that's in. It's like IP tools. It's something. I can never remember this. But anyway, so we can do an nsenter. And then here we're going to say we want to enter the same network namespaces. Wait, we need that process ID. What was the process ID? Why does that say 2? Did you see that? The first time it said 2 and then it said top. Okay.
Yeah.
So
4.2.
Here what we're going to do, we're going to say nsenter. So what we're telling my host, we are on my host right now, right? Okay. So we're not in Ubuntu. So we can run nsenter here. We can say, I want you to share the same network namespace as this target process, which is 841.690. And then we can run commands inside of it. Okay, sudo. So now we're not getting, right? This is my host. This is what's inside the container. And so that also brings up, I guess, another question about like how do you debug containers? People will often like install all of the tools that they need in the container to debug, and you don't need to do that. All right, let me scroll back and see what questions we have. Feel free to add in thoughts here, Aaron, while I do this.
Yeah, well, I don't have much to add. I actually learned stuff there with the nsenter example. I would say containers are not VMs. I want to just repeat that point. It's very important to remember that they are good for packaging because they give you the zip file thing. They are good for distributing because they have a standardized API for pushing them up and down to repositories, which processes don't necessarily have. So it's good to remember that distributing them is a lot easier, regardless if you're on a huge system or you just have your laptop and a server that you've got to move your app to.
Okay, so do you want to take this question that just joined? Sorry if this has been asked, but does it make sense to use Kubernetes if I just have one server and just like hosting like 5 to 6 containers? And I'm just grabbing a couple of questions out of here so we can get caught up.
Sure. Yeah, I think it depends what you're doing with them. My hunch is that you're running the containers for maybe a web app or something like that, some background job maybe. If you need something complex, like you need them to communicate in some exotic way, maybe you need them to have to be able to have high availability, or at some point you need them to be able to scale up to multiple replicas of each of those containers. Those use cases might be a good reason to use Kubernetes. But we kind of mentioned this before too, is Kubernetes is a big undertaking. If you learn containers at some point in the past, Kubernetes is probably 5 times the amount of things that you've got to learn before you can get your app, your containers running in it. So be aware of that. Does it make sense? It's hard to tell depending on what you're actually building. But my hunch is that you're doing, like I said, maybe a web app or some background job or something. And in that case, probably doesn't make sense unless you've got more complex use cases like that.
All right, so I saw Hello, I'm JVB left, but we're gonna give him a shout out. He's an engineer at Rancher, and I guess he's gonna be streaming later as well about with the Kubernetes release team. Okay, so we've got a bunch more questions. So this one's related to what we were just looking at. What is C group and systemd C group? Okay, that is a very good question. So containers are actually just applications that leverage a couple of kernel features. So one is they use something called chroot, which basically limits what slash is, how far back up the tree the process can traverse. Most people who use Linux are familiar with that. So C groups and namespaces are the other two. So C group stands for control group, and that is basically how we enforce resource constraints on a process. How much of any given system resource can this container consume? So that's all that is. We bucket them into a C group, and say this C group can use 5 CPU shares or 200 megs of RAM, and that's how those are enforced. Then the second thing are called namespaces, which is what you saw me do here. There's network namespaces, PID namespaces. I mean, we could go into a whole list of all of them, but that's basically like, what can this process see? What other things on the system can it see? Can it see only the processes in its same namespace, or can it see all of the processes? Can it only see the network interfaces in its own namespace? So that's all we're doing here, is we're basically telling the kernel, hey, I want you to run that command in the same network namespace as this. And fun fact, if you do a Docker exec or a kubectl exec into a pod, this is basically what it's doing, right? It's executing your new command, bash, except it's telling the container runtime to put this process in the same namespaces as the other ones. And it's also how pods are able to communicate with each other, because it just creates them in the same namespace. Okay, next question. Can I crash the system with containers, or is there like an if switch? So you can crash the system, and earlier I kind of shared a mean thing I would do to people in a cluster or in workshops about Kubernetes, where we would get people to set replica sets and not set any CPU constraints and scale them to something ridiculous. And not only can you bring the whole node down that way, you can bring down the cluster, because you can overschedule a node, right? You can put too much work on there where you saturate it and it's no longer able to communicate just the same way you could. Is there maybe there was a more specific question there, like if the app crashes, does it crash? Is that can the container run a different kernel version than the host it is running on? It cannot. It cannot, and the reason for that is kind of what we just demonstrated here. There is no virtualization of the hardware. So in order to have your own kernel, the kernel is responsible for talking to the hardware, right? So in a VM world, you have software that imitates hardware, which means that you can have an operating system talking to this fake hardware, right? In the container world, that's just not true. It is just a bunch of controls put on the process to control what it can see, what it can do. There is no virtualization of the underlying hardware, except for Windows, and then you can call me a liar because it legitimately is. Or if you're running Docker for Windows or Docker for Mac, then there's a VM that all of that crap's running in. But, well, I guess Docker for Windows and Docker for Mac, it's one VM running your stuff and not each individual container.
Yeah, so you're bound to the kernel that VM is running.
Okay, so what do we have here? We already did this one. Can I crash the system? What's the best way for me to do in-cluster CI/CD with Kubernetes? Commit to repo, build image, propose build changes as build request.
I've got two answers to that. One is GitHub Actions allows you to run your own build agents. So it's kind of similar to how we talked about the kubelet, actually, where you've got the kubelet sits on a node that does the work and it talks up to an API that controls it. It's kind of the same thing with actions. You can get their little worker process, set it up in your pod, and have the worker process talk back to GitHub to figure out what jobs it should run. There's another system called BuildKite, just as run by a smaller team, and they have effectively the same thing, where you have their API, their web interface. They've got some more things around proposing changes, release management, and so forth built in. But it's the same idea: is you install their agent on your hardware or your pod or whatever, and that thing gets the work to do. It pulls down the code. It does whatever it needs to do according to your CI job.
Yeah, and there's also some services too that are like this too, right? Like Azure DevOps and stuff like that. There's some there's some container registry providers that offer some functionality here too. You know, maybe not necessarily like the proposed changes and stuff like that, but if you're already using a tool for that, like say GitHub or something to manage approving changes and things like that, and then merging into a repo, there are some container registries that can pick up on the fact that a GitHub repo changed and then rebuild your container and store it in the registry too. So it sort of depends on like what your level of workflow looks like, right? Like, so some people are going to have much more advanced pipelines for approval processes and change management and things like that. And other people may just be looking for, hey, I just want when this is committed somewhere, I want an updated image. And so maybe using one of those registries is probably an option there. We should probably also talk about, if you're not familiar with CI or multi-stage Docker builds for CI/CD, that's kind of what's crucial there, right? Because we need to think about the fact that there's a difference between build time dependencies and runtime dependencies, and so this is where multi-stage Docker containers come into play, or Docker builds, I should say. And close that on accident. And I actually have one here as an example, right? So this is one for
Nice.
a project that I'm working on right now, right? So this is kind of looks normal except for this like as build part, and we'll get to that. So we have to install all of this stuff in here, like automake and compilers, like this whole build essential. We don't want any of that in our running container because one, it's going to make it gigantic. Two, if I manage to say like find a vulnerability in your web app and I get in your container, now I have a compiler and all kinds of crap at my, you know. Uh, so we there's a number of reasons we don't want that, right? So what we can do here is like here we're installing the Rust compiler and stuff. We don't really need or want any of that. So inside here, we can actually see there's a separate from line. And so this build takes place, uses all the same caches as normal, except when we get to this line, here we're starting from another base image, and we're only installing the stuff that we need at runtime. And you can see here, these are the important lines. So we're copying this file in this path from the build container and storing it here. And same thing here. And so we're able to basically create a temporary build container that has all of the build time dependencies in it. It produces the artifacts, and then we copy them over into a much smaller runtime container. So when you're doing CI/CD, this is kind of like a cool way to do this, because now your entire repository has all of the information it needs to both build it and run it and produce a smaller image. Okay. Tips on security in containers. Yeah. So don't run things as root. If you are, let's see here. If you're running in Kubernetes, network policy, security policies, or pod security policies, all of those things are crucial. Ensure that if there are hard security boundaries between applications in your system, that you are not running them on the same node, just because security, if I were to break out of the container, I would then get access to everything on the host, especially if you don't have any of these security policies in place. You can actually secure your containers in such a way that you can limit the syscalls that your container is able to make. There's some tooling out there like Falco and Aqua, and Tigera has one that can do some monitoring of syscalls and tell you when containers are making syscalls that they don't typically do, so that you can do some security stuff around that. Am I missing anything right now?
Not really. Your multi-stage thing was a great point, though. Keep your containers small.
Yeah. Anything you can do to minimize the attack surface is huge. Oh, RBAC. RBAC is huge. Yeah, like please do RBAC. Rotate keys if you're using Kubernetes. Like don't leave people in the cluster. Don't expose your cluster's API server to the open internet or your kubelets.
There actually is a good use case for service mesh here, because with service meshes in Kubernetes, you can lock down a pod to only a specific other endpoint. So if you have, let's say don't do this, but let's say you're running someone else's code that you don't trust in a container. Well, if you set up a service mesh, then it will prevent their container, whatever code they have in their container, from talking out to some arbitrary endpoint.
Yeah, and you can use network security policy for that too.
Yeah, good point.
Yeah. So who was it? Oscar Allen made a good point here too. Multi-stage builds are also great since you can keep sensitive information in the build image and avoid letting them leak into the runtime. This is actually really good advice. And I will also add to this, if you are running an application in Kubernetes, you also have at your exposure in a pod definition the ability to supply an init container. And so what an init container is a container that is executed before any of the other pod or any of the other containers in the pod are created, which means you could have an init container that runs and does some things, and maybe that init container has access to the keys to generate a cert or something that the containers inside that pod might need. But then those things are not stored in the pod, which means if I were to gain access to your container, I'm not going to be able to get the keys, right? I might be able to get the cert that only lasts some period of time, but I'm not going to get the initial key that signs things, right?
Yeah, don't bake in any secret information to your Docker file anywhere.
Okay, so
And also one last thing is try not to bake in any configuration, even if it's not secret, into your Docker file. Get that in via Kubernetes primitives or something else.
all right. Does anyone know a way to create a worker node where only specific deployments or pods can be scheduled? Absolutely, Mr. Bananas. What you are looking for is called a taint. So Kubernetes taints and tolerations. Okay, so no, there we go. We're going to pull up this doc. I'm going to link it to you. And so basically what this allows you to do is when you say taint this node, we're saying here that the taint is called key with a value, and we want it to be set to no schedule. So what this means is the scheduler will refuse to schedule anything onto that node unless it sets a toleration here of key equal to value. So that's what you're looking for. So you're going to need to do that, but then you're also, if you only want, so these things kind of work hand in hand. So taints and tolerations allow you to restrict things from running on this node unless they explicitly say I'm allowed to. However, that does not tell the scheduler that that's the only place that your workload should run. So you're going to pair this with a Kubernetes node affinity selector. And the node affinity selector is what's going to attract your pods to nodes that have specific labels. Do you have anything to add?
I don't remember. Is it guaranteed? I know node taints is guaranteed, but is node affinity guaranteed?
Yeah, so any of your selectors, your node affinity and pod affinity selectors, have two options, or four options technically. So you have a required during scheduling, and then you have a required during execution. And the difference between those two are if I change the label on the node while something is running on there, does it eject it from the node and things like that, right? Or do we only care at the point of scheduling? And then we also have preferred during scheduling and preferred during... I
got you. Okay.
Yeah. So this allows you to kind of create a scenario where you're like, okay, I ideally want these things to run here, right? So we could do a preferred, like I would prefer these things not to run. I would prefer these things not to run in the same rack. Let's say you label all of your machines based on the racks they're in, right? So I prefer these two replicas or whatever to not run in the same rack, but I require them not to run on the same node. All right, let's see. Lots of great questions. Okay. Kate secrets secure. Okay. All right. I'm trying my best to keep up here. Please ask again if you didn't see me add your question to the doc. Okay. Also, what's the best way to save and reload development? Something with microcates, scaffold, and others. So when you're saying this, do you mean save like the current state of your cluster? Is that what you're referring to? Heptio has a project called Arc, if that is what you're referring to. And arc, and that will allow you to back up all of the stuff in your cluster, like what resources are running. It'll also allow you to mirror it. So if you want to have like 2 clusters and you create something in this cluster and you want to also be added to this cluster, you can also use Arc for that. Do any of you have experience with BSD jails? I used BSD in the early 2000s. I vaguely remember using BSD, so I probably can't speak much to that. Okay, earlier question. What about you? Do you have any experience?
Never.
Okay.
Never used BSD.
All right. Obviously, running things in Kubernetes is great for many reasons, but are there parts of the tech stack that you would absolutely not run inside Kubernetes?
I can take this one.
What's that?
Let me say one thing real quick about it. I actually scrolled up. Someone said databases.
It's actually, yeah, it's in here.
Okay, right. Yeah. That's probably true for a lot of databases. There are some operators that will run like a Postgres for you or whatever. Storing long-lived state in Kubernetes is not the greatest idea because carrying around a volume that would store the long-term state is very slow and can be slightly unreliable as well. But if you're talking about something like Memcache, or if you're using Redis with eviction, so kind of as a cache, that's fine. That's fine to run in Kubernetes because you don't care if the data gets lost. Obviously, if you've got like a production system that requires that a TTL is respected to the second, that's a different story. But I would say, generally speaking, a cache probably is okay to run in Kubernetes. Talking about data.
Actually, I'm going to move this one down because these are almost all associated with each other. Okay, so I would agree. Databases are tricky. We're getting better, right? I will tell you that stateful apps in Kubernetes are significantly better than they once were. But you know, if you were running like a small shop, you have a small app, you're running your own little site or something like that, and you want to run Postgres or something like that in Kubernetes, you're not going to have that big of a problem. The latency probably isn't going to be that big of a deal. If you are running a large scale shop, you are probably doing lots of custom things and you are customizing the crap out of your MariaDB or Postgres or whatever you're running, and often down to tuning hardware configuration, right? Like I know, you talk to a database engineer at Twitter and, they're going to tell you about all the custom like kernel stuff that they're doing and configuration that they're doing. So that becomes problematic because, again, remember when we talk about like this distributed system with a declarative API and pets versus cattle, we don't want any special nodes, right? So the tuning that you do to get your database to perform really, really well may also make your web app perform poorly, right? So you end up in those situations where you have a special snowflake in the cluster. And yeah, so, but I think that as we do more things, right? Like things like CSI and things like that, we're going to get there, right? Where some of those things can take place. But you may actually custom tune the nodes in your cluster and then taint them and only run the database there too. So I would say this is getting better. Try at your own discretion. But
stateful sets are getting a lot better specifically, I think.
Would it not be okay to host a database in a container as long as your storage volume is not terminated when K8s recycles containers? So the difficulty with this is how storage is mounted in, right? So a stateful set, no, yeah. So the difficulty with this is not necessarily the fact that we've containerized the database and we're running it in a container. It really becomes storage. So when that container fails over somewhere, the storage needs to be replicated. And this is actually a hard problem in general, right? This is why you typically have this is typically why you have database replicas and they forward their log, they ship their logs over and all of that stuff, because trying to sync the disk itself is really, really tricky. So that's the thing to be careful of, is it's not that the binary is running in a container, it's that when that binary goes down and it's rescheduled to another node, what happens with the disk, right? Mm-hmm. And so you're pretty much forced to use some sort of cloud storage, right? Or something equivalent, for your local network. And so you're only going to be as successful as that shared storage system is for you, right? And how you hand over that stuff with, distributed locks and things like that. Yeah, stateful apps in general are difficult, especially when you're talking about distributed stateful apps, right? Mm-hmm. Yeah, you get the whole CAP theorem, right?
If you're in Kubernetes, even if you use a node affinity and a node taint, and you make sure that nothing else runs on that node but your database, and it's one pod, you're still in a distributed system, and you still have to think about the CAP theorem, like you said, Eric.
What is CSI and flex volume? Oh, we got a whole bunch of follows here too. Thank you everybody for the follow. Also, make sure that you follow Aaron here as well. He is also a streamer here that does a lot of content on cloud native stuff. Okay, did you want to hit CSI or do you want me to?
I don't know what flex volume is. So
that's new. That's new to me as well.
Okay, it's new for both of us.
So I'm guessing it's something somebody has created on CSI. So CSI is
check out
container storage interface. We talked about the container runtime interface, which is sort of like the API, that generic API that needs to be met by some runtime. We talked about the container network interface, which is the same thing for the network plugins. So CSI is the new storage interface that is being worked on, and I'm actually not entirely sure the state of that. I'd have to look up what flex volume is. This is the fun thing about the Kubernetes space, is this ecosystem is moving so fast. You've got all the different layers of things, like what's happening in Kubernetes proper, what's happening in the service mesh world, what's happening in the operator world, and all of these things. It's almost impossible to keep up with. But maybe Aaron can touch on that once he looks up what it is and gets a general consensus of what that is.
Yeah, there's not a lot of docs on it. It's existed, it's out of tree. It's existed since 1.2, which is pre-CSI, uses exec-based model to interface with drivers. And that means the driver binaries have to be installed on each node, pre-installed on each node. So CSI is a standardized way for anyone to build a storage driver. So it sounds like flex volume is, or it sounds like CSI is the more generalized, probably more convenient way to get access to general storage inside of your cluster. And I mean, Kubernetes, anything but a purely stateful app with an ephemeral file system, anything beyond that, CSI makes that happen.
Okay, next question. This one's going to be an interesting one because we both work for Microsoft, and I know what my answer is going to be. What is the status of Windows containers and their support in Kubernetes? Yes.
They are supported.
Yes. So yeah, Windows containers are now in the new Kubernetes releases. I can't speak a lot to them. I haven't done a lot of Windows stuff. And so therefore I also have not done a lot of Windows container stuff. I will tell you that Windows containers are actually trimmed down Hyper-V containers. So they took the analogy everybody made about containers being lightweight virtual machines and made that a reality. So Windows containers are that. They are also significantly larger because the kernel is not separated from the operating system as a whole. So, they are many gigs at their smallest.
And they're kind of sold as a way to take your older school Windows app that's on like .NET or whatever, and just take it and run it on Kubernetes or in a container somewhere. So it's a slightly different use case than building your microservices on Linux containers. But it's cool that you can take that and integrate it in with your cluster. Say your cluster has a bunch of new microservices on Linux containers, and you bring in your older Windows app, and that's in the same cluster.
Are Kate's secrets secure enough for managing secrets in Kubernetes, or would you recommend using third-party integration with tools, HashiCorp, Vault, or Conjure? Yeah.
I would go with
Yeah.
Vault, or if you're
Yeah.
so secrets can't, with some work, secrets can integrate with Vault or other secure backends. But remember, if you go in and do a kubectl get secret -o YAML, you can see the base64 encoded data. So secrets can get hooked up with some work to Vault, and then that doesn't happen. But I would go, if your app can use Vault out of the box, go with Vault. If it needs to use environment variables, hook secrets up to Vault, or using a init container that can talk to Vault and then set the data into the file system somewhere. Or more likely, this is one I prefer, is use your cloud provider's store. Key Vault in Azure, Google Key Storage on GCP, I think. I don't remember what they're called on the others, but they all have a thing like that. And then you don't have to run Vault.
Yeah, and that's sort of my opinion too. You can use them, and it just depends on like what security practices do you have? Like what's the adverse effect that happens if somebody gets a hold of that secret? But it's not a great way to manage secrets in general, right?
Yeah.
It's not even just about like how easy it is to get them and base64 encode them. How do you rotate them? How do you manage who has access to these secrets? How do you like revoke these from other people? Where's the audit log to tell me when people have accessed these things? So there's a lot that goes into that. But as Aaron said, there are ways to actually connect this so that they are actually implemented by your cloud provider. But yeah, all of those tools are going to be significantly better if you just use your cloud provider's options for those things. They usually have ways of rotating the keys and an audit log of who has access to them. And many of them have APIs where the application can be triggered when the key is rotated so that it can grab a new one. That's the route I would go. I typically use, it's also called Vault. I typically use Azure's Vault for managing secrets like that inside of my containers.
The reason I say like you can go with the cloud ones is because there's a concept in Kubernetes called pod identity, which most of the cloud provided Kubernetes will set up for you. And that allows you to write code that runs in your pod in the cloud to just go and access your stuff, whether it's your queue, your database in your cloud database, or your key vault. So your app, without a lot of work, can go and read the secrets out of the key vault on startup and then use them.
Yeah, that's actually ridiculously helpful. Is the managed identity stuff, where basically by virtue of running in the cluster and being this application of this type, the Kubernetes cluster is basically grants you a service principal. Is like, oh, okay, we know that you're this application. We know that you have access to these secrets.
Yeah.
All right.
There was an interesting one pretty far above by Oskalaran saying, do you think that Kate's is here to stay? Do some of the containers like Mesos or Nomad have something else or better to offer? I thought that one is kind of similar to one that was recently. Because is it worth learning working with Swarm and then go to Kubernetes? So I wanted to, do you mind, Eric, if I talk about the Nomad Mesos thing?
No, let's, I'll move that up, talk to that, and then we'll add in Nomad, Mesos. Okay.
Cool. Yeah, so Mesos is used in some huge shops. So Mesos is not going anywhere. The community is slower than Kubernetes, but then again, Kubernetes was the fastest growing app, the fastest growing project on GitHub ever. So nothing goes as fast as Kubernetes, which is good and bad. Kubernetes is also here to stay because big shops use Kubernetes too. And there's so much technical investment in these big shops that Kubernetes just can't go away because they're invested so heavily. And the same thing goes for Nomad. There are big shops using Nomad too. So that being said, like none of these are going to go away. It really depends on what you need. So if you need Kubernetes, heavily supported, widely contributed to, fast-moving project, something that is not going to go away in terms of support and in terms of future development, that's Kubernetes. If you're looking for something that is officially supported by a company and has a lot of up-to-date development, Nomad. Kubernetes and Nomad are very battle tested, but Mesos has been around the longest and is battle tested in a very specific set of use cases. It also has a very different type of plugin architecture. So that being said, Mesos may fit for especially situations like big data processing.
Yeah. So, I would say that like they kind of find their pockets, right? So Kubernetes is kind of, this is sort of like where we've democratized distributed systems, right? And so this is sort of like the API that most cloud providers have kind of like settled on. So everybody's, this is the way you're going to consume CPU, right? And Mesos is really around kind of the pocket that it fills most, right? There are people who use it for this, is custom distributed systems, right? Doing big data processing, all kinds of things where you want to manage how your workload is done. However, rather than running a binary somewhere, it also has the ability to run your thing in a container. So we find this too. So we have to really look at like the problem spaces these things solve and not mix, well, all of these things use containers. It's like comparing all services that run processes, right? Containers have really become a way of packaging and distributing applications. So the fact that each one of these uses containers does not necessarily make them direct competitors in all spaces either.
Yeah, one note about Mesos, I think it's pretty interesting. Mesos originally was just like Kubernetes. It was a way to schedule stuff, not necessarily containers, but to schedule compute onto a bunch of resources in a cluster. And Mesos split out and became raw Mesos and then the frameworks that run on top of it. So raw Mesos is just, here's the list of resources and here's where they are. And then the frameworks on top of them are the ones that do the actual scheduling. So there's a framework for long-lived stateful servers, and there's a framework for big data processing, and there's a framework for all these different things. So that different architecture is worth keeping in mind as well if you're going and trying to choose between these things, because Mesos is very different from the other two in that respect.
All right, so the next question is, any advice on what tools and patterns methods to use when trying to apply zero trust in your Kubernetes setup? Yes.
Do it? I don't know.
Yeah, so sorry, responding to people. Okay, so somebody in chat earlier mentioned Spiffy. Oh, it's a link right here. So that is one place to look. As well as you need to secure the binaries themselves, right? All the supply chain security stuff that you would do in a typically secure environment, you should totally do that. There's things like open policy agent, pod security policies, network security policies, all of those things you should be doing to limit what things can talk to each other over the network, what things have access to. Absolutely never run anything as root in your container. Make sure you're practicing good security hygiene on the host, because if I happen to pop your container and I pair that with a kernel vulnerability, then I now have access to your host, RBAC, rotating keys, making sure that we're practicing good hygiene with who has access to the cluster. Do not expose your API server to the public internet. Because the thing I like to tell people too is now the control plane is basically, it is
It's like getting access to syscalls.
yeah,
Public access.
yeah,
to syscalls.
so it's not even that. It's I'm like losing my train of thought here. It's the equivalent of popping the domain controller in a Windows environment, right? Like if you get that, you own the world, right?
Yeah.
And so that's the whole thing. I actually submitted a proposal for a talk at DEF CON where I wanted to like go through like all the nefarious things that I would do if I gained access to your cluster. And because you could make every container inject a sidecar process that extracted stuff, right? Like I could just introduce IP tables or traffic control policy rules to just like randomly give you network. Like that would be my thing, right? Like I would screw with people in really crazy ways that would just annoy you. Like, why does networking just randomly fail on this? I don't understand. Because it would just go away and come back and things like that.
Man, that IP tables one though is really nefarious. Send the credit card up to me or whatever.
Yeah, and so like you could get access to spin up more resources because oftentimes the cluster has keys to be able to do that, to spin up more nodes and things like that. Like, so you need to treat it just like any other thing, and you need to look at when you're securing these systems, you need to treat that the same way you would the domain controller in your Windows network. Like you just wouldn't, you wouldn't run publicly accessible software right next to the domain on the same host as the domain controller, right?
Yeah.
What will be the advice for a beginner? Nilam, is that in like getting started? Are you looking for like an intro to Docker and Kubernetes? Okay, so let's see. I hope I covered all the security stuff there. Whoa. Okay. There are also some really awesome people in the security space in the Kubernetes world too. I would definitely recommend following Ian Coldwater as well. They are doing amazing stuff in that space and always blow my mind with some of the new things they come up with. Okay, let's see. What will be advice for a beginner? Okay, we can touch on that as well. Let me put that. Okay, opinions on Fargate. When you say Fargate, do you mean the product or do you just mean the general? Do I have caps lock on? What am I doing there? Or do you just mean like serverless Kubernetes in general, like or serverless containers? I have not used Fargate myself, but I do like the idea of nodeless Kubernetes, right? And so I worked on a project a few years ago, 2017, called Virtual Kubelet, was like experimenting with this because right now the notion of a node is very, very highly tied to Kubernetes, but I do love the idea of, right, like Kubernetes is awesome for all the orchestration and service discovery and all of these things that we get from it, but we still end up in this position that we still have to capacity plan, right? Mm-hmm. How many nodes do I need? What CPUs should they have? How many GPUs do I need? All of these things, and then we take these things that we've done all the capacity planning for, we provision them, and then we tell the cluster how to use those. And we get some things like doing man, my memory is just going crazy. I'm losing my train of thought. So we have the ability to use like the horizontal pod scaler to say, okay, I need more of these. Perfect. Okay. And then we have the cluster autoscaler, which, adds or removes nodes. So that's getting closer, right? But the dream is like, I just want to throw my work at this cluster and say, you figure that crap out. right? Like, I don't care how you do it. I just want 5 of these things running. And so I think that is the best end goal if we can get there, right?
Yeah, and I think there's a second angle to it also, is that these serverless container platforms can be really good for people who just want to take their container and run it in the cloud, and the cloud needs to figure out how to scale it without learning any of the Kubernetes stuff.
Yeah,
So it goes both ways.
and we have things like that. I'm going to speak to Azure here, but we're trying to be as agnostic as possible, but I'm not as familiar with the offerings for Google and Amazon. Maybe Aaron can help fill in here. But there's also things where some of these tools are starting to leverage APIs that already exist. So I know Azure's container instances, you can actually set up a Docker context, and then you can just use Docker Compose locally. You just switch your context and say, I actually want all of this to deploy to Azure instead of running locally. And then you just run all of the same Docker commands. And I'm sure the other platforms have these things too. I haven't caught up with some of them. I haven't played with them as much recently.
I don't know about the Docker Compose support, but I know there are others. I think Fargate, yeah, I mean, I think Fargate can integrate with, yeah, I'm reading it now. It can integrate with ECS, and so you can run stuff on Fargate without necessarily using Kubernetes, but I don't think there's Docker integration. On the Google side, there's Cloud Run is the closest thing. Same thing. I don't think they have Docker integration, but it is one of those systems you just deploy your container.
We will see over time, right? Like all of the cloud providers inevitably end up with the same or similar features anyway, right? So I tell people that all the time. Like if you're choosing a cloud provider based on the features that exist today, it's probably short-sighted, because in a week or 2 weeks or a month, they're all going to have that feature, right? If it's something that everybody wants, they're all going to have it. So
just wait.
Yeah. So I wanted to touch on a question that was asked earlier about something that I said. So I mentioned the horizontal scaler. So what the horizontal pod scaler is when the CPU usage of all of the instances of your pod or your application, for anybody who's new to Kubernetes, pod will just refer to generically as an application. So when the CPU usage or memory reaches some threshold, the cluster will automatically increase the number of replicas. So let's say it's a web server, and then collectively the CPU usage across all of the running instances of your web app hit 80%. Well, then the cluster is just going to automatically say, okay, well, we want another one running. And when it drops below some threshold, then it will remove them. So that's how basically you can get it to run more instances. And then when we talked about the cluster autoscaler, that one will look at the CPU usage of the nodes, and memory of the nodes. And when those cross some threshold, then we're going to add or remove more nodes from the cluster.
Someone mentioned thoughts on Knative and OpenFast, and that ties right into the pod autoscaler. I don't have a lot of. I used OpenFast once, but not in production, just like in dev to try out serverless.
Same.
I've used Knative quite a bit more, and they are both they're big projects. So this is not the only thing they are, but they both build on top of that pod autoscaler. So Knative gives you sort of serverless containers on a not serverless system on Kubernetes. And it allows you to give it a container and then start scaling based on HTTP incoming traffic, actual requests, and go that one level above CPU and memory. And I really like that concept. I like the OpenFast concept too. It's, give it some code and it figures out what container to run it in and how to run it and so on. And yes, does Knative scale to 0? I like that too. It's pretty cool.
Yeah, and I think
I want to mention one other project called Kata. I've been working a lot with Kata recently, and it doesn't do the HTTP ingress. It's more around different queues, like SQS or something like that. It's around scaling up and down the workers to do that queue processing work. But same idea, it ties into the pod autoscaler.
I somehow deleted the question that was about the beginner stuff. I'm just going to put beginner stuff here to remind me to ask when we get to that one. All right. Kate's covers lots of stuff and makes ops boring, which is good. It's totally the point. What's the future of Kubernetes? Are we reaching the pinnacle already? I don't think that we have reached the pinnacle yet. I think more people are going to adopt it as more people shift to cloud. The requirements of these types of systems will become baked into here. I also think that my personal thoughts on this are, I think that we're inevitably going to reach the point where the pendulum swings again. And I'm trying to remember who gave this analogy. Maybe it was Joseph Jacks. I can't remember. But, or no, it might have been, I can't remember. But anyway, when we think about like technological advancements, it's almost like this pendulum swing, right? We typically go, up and out, right? We build some abstraction for something that we're doing in our code all of the time to abstract that away. And then, we get that. And then we end up swinging back to down and in, where our code now defines how that should work. And so while we're starting to define what the API looks like for how do you talk to hardware, how do you talk to operating systems, how do you talk to clusters, that's what Kubernetes is solving, right? It's building that abstraction layer for how we as engineers declare what we want out of our infrastructure. So we've got that layer, but nobody wants to manage YAML files, right? So
yeah,
where, we still have to solve that problem. And that's going to be what's going to be interesting over the next several years is, what do those things look like, right? How do we start communicating with in a better understood way with Kubernetes? And there's been some interesting experiments to that, how we end up like what the metaparticle thing. I don't think it's maintained anymore, but that was sort of like this thought of like, in my code, what if I declared that I needed this to be replicated, and it's a leader-follower relationship, and it's sharded, and these are just things I define in my code, and then at compile time, it generates everything that I need for services to do things, and service discovery to find which shard is responsible for this piece of data, and generates all of the YAML files or Helm template or whatever it needs to just run this as a whole, and maybe even deploys itself, right? And
that was a cool project.
Yeah,
I liked that project.
And so and I used to tell people, like, I don't know whether that's the answer, but I love that line of thinking, right? I love these experiments of like, they could be everything or they could be nothing at all. And so I think that's an interesting thought is, what does this look like 5 years from now or 10 years from now? I don't think you or I are going to be talking about YAML files or even the individual service definitions.
There's I think this Kelsey Hightower said this publicly. He said Kubernetes is a platform. And that really resonated with me. Because we've kind of seen this pattern in the past of building up. So like, look at the iPhone. Before the iPhone, all the raw materials were there. You had touch screens, you had tiny memory, you had whatever else. You had 3G at the time, you had Wi-Fi. The iPhone was one of the people. They did it pretty well, but they were only one of the many people who were able to put all that together in a great way, in a way that made sense to everybody. I don't think anyone has, there are some, I think, who have started to take all the raw materials of Kubernetes and put them together in a way that makes sense to a group of people. And I don't think we're going to see like a ton of more just greenfield development of Kubernetes APIs. We're going to see the APIs be driven, the new APIs be driven by those projects that go on top of it, that put these things together. So, if you look at Knative, Knative actually did drive a lot of improvements to underlying Kubernetes stuff. And Knative is one of those things. It puts together all of the Kubernetes things that are needed to get really awesome HTTP based auto scaling pods together and do release management and rollouts in blue green and all that stuff. So I think that's the future. Is we're not like, if you look at K8s, the software, maybe there are going to not be so many new APIs developed over time, but it's certainly not the pinnacle because there's going to be so much stuff built on top of it.
I just, Sebro just pointed out, you got like a really low frame rate here. I haven't had that issue before. Hold on, let me.
Oh yeah, I do.
I'm going to just refresh you really quick and see whether that.
Okay.
All right, move, dance for us. Better, but not quite the same. Interesting, because I've never had this issue before with, because we've used this in the past.
Yeah, maybe I can rejoin. No, close settings. No.
Yeah. See, bro, like we've had that. We've used it in the past before, and it's usually pretty solid like that. And it's not a network issue for sure. I've got like a 1 gig symmetrical connection here, so we can get all of the people here on the call.
Let me try. Yeah, I have a gig. I just did a speed test. I'll try rejoining as well.
When does it make sense to set up your own Kubernetes cluster, and when to use managed instances? I would probably default to. And to answer your question, he can't see my screen. So I would probably default to using a managed instance, unless you have people who can dedicate themselves to managing it, understanding how the control plane works, what its failure states are, like when you see some sort of adverse side effect. Do I have double U? I might have double U because you just rejoined. Yeah. All right.
Sorry.
All right. Now you're fixed. How about now? Are you good?
It's a little choppy. I think it's better than previously.
All right. We might have to figure out another tool in the future.
Yeah.
Maybe one day we'll get the RTMP switcher working.
Hey.
Oh, you know what we could have done that I didn't think about? I guess we could have done like a Discord call. But
yeah.
I could have had you push your OBS to just an Nginx server that I set up, and then we could have just pulled you in with a VLC plugin. I bet you that would have been rock solid. We'll try that next time.
I've just straight up shared a Discord window before. It worked fine.
So Sebro here works for GCP and also agrees. Use managed for everything as long as you can, especially if you can drop down to self-managed in the future. Yeah, yes. I mean, because that you're kind of removing the whole benefit to this, right? Like the whole idea is like, I just want to declare like, here's my application, run it for me, please, right? Like that's the dream. And if you're managing the cluster, that's just, you're taking on a lot more work. The more stuff you can let somebody else do for you, the more time you can spend working on your own application. You know, there's inevitably going to be people who have specific use cases, right? Like, so the example, like the talk that I gave, I don't know whether I linked it today, but you know, that we referred to at KubeCon, where we're talking about like what we did with Comcast. Well, they have their own internet backbones, and these things need to run in head ends like locally, almost like a CDN. They have very, very unique requirements that like 99% of people don't have. So they're always going to be in a situation where they have to run their own cluster. But for most of us, you know, if you're running an e-commerce app, you don't need your own servers and your own clusters and all of that stuff. Just managed. Like,
I would also say it's kind of like in programming. If you have a public API, it's pretty hard to go and make it a private API because like the genie's out of the bottle. Same thing here. If you are self-managing everything, it's kind of hard to go up and use a managed thing in the cloud because like you've done all the work. It's kind of the same. The genie's out of the bottle, so to speak. So I really that really resonated with me, Bro, when you said you can drop down into self-managed in the future. That's a lot easier to do because that's kind of saying, well, okay, I put in X amount of work. Now I need to put in that extra work in order to go down to self-managed, as opposed to the opposite, where you just waste all of your time up front, and then you might end up wasting all that work anyway to go back up to managed.
Personal opinion: Kate's orchestration platforms, Rancher, etc., or pure Kubernetes? I don't. So this one's difficult for me because I've used Rancher in the past. I've used like CoreOS and Tectonic and things like that in the past, and so they offer a lot of value. There's some cool features that exist in those products, and then also you're paying for the support and some of those things that they do. Many of them use just vanilla Kates under the hood, right? And even managed providers, right? Like, what's provisioned for you inside Azure when you spin up AKS? Or Cbro could speak better to this, but I'm pretty sure GCP is the same way. It's just spinning up the same Kubernetes you could have done yourself. It's not like a custom version of Kubernetes that's patched specifically for there. Everything's kind of that's cloud specific is injected inside the like cloud controller manager and things like that. So what you're paying for is a system that provisions all of this stuff for you, gives you a UI to interact with it and things like that. But under the hood, you're still getting the same vanilla Kubernetes.
They pay for the control plane compute usage too, and the etcd and stuff. That's always nice.
Yeah, and but I mean, we're mainly kind of talking about like the differentiations between running some platform versus another. Although we did talk about OpenShift, right? So
right.
There are some instances where it is more opinionated, but most of the providers that I see for Kubernetes are just what you're buying from them is a different way of interacting with vanilla Kubernetes. GKA does have some enterprise features, but I'm pretty sure you can use those even if you use self-manage. A lot of it is set up and managed, Istio, Knative, etc., but those are things you could set up yourself. Yep. It's the same thing, right? Azure's is the same way. Like, you check a box and it installs and sets up something for you. So what you're paying for is kind of the ease of use and setup and provisioning and all of these things, or some of the integrations with other things in that environment where they're like, oh well, we're going to ship the logs off to Log Analytics, or it's escaping me, GCP's one. Stackdriver, right? So like you're paying for those kind of integrations where we
talked about pod identity before. That's nice. It's like set up for you. That's just another example of the convenience factor.
I forget who asked the question about beginner stuff. If you are still here, we have reached your question. I think it was Nil something. Did you have what was the question? I can't remember. I somehow accidentally deleted it.
I'm gonna see if I can find it here.
Okay. Semi-serious question. Should we rewrite Kubernetes in Rust? Wow, like shots fired.
I mean, should you rewrite a Linux driver in Rust?
Yeah, so I will say that my general answer, no question mark. So the reason for this is like there's a lot of components there. It would be a gigantic effort to rewrite, and the entire ecosystem is kind of leveraging Go. However, exceptions. I think that we do need a good Rust client library. I really do. Generics would be huge for that. So can we please rewrite kubectl in Rust? Kubectl, please. That'd be
cool.
I would also really love to see kubelet and kube proxy please. The reason for this is then we can start thinking about running Kubernetes in places that we currently cannot run Kubernetes. And maybe not all of Kubelet, something Kubelet-like, right? Like kind of how the virtual kubelet or a crustlet or something, because Rust has the advantage that we can run it with no runtime, which means we could get to a point where we can run it on embedded systems that are not necessarily Linux. So as we start thinking about like Kubernetes as like an API for building our own distributed systems, I would love to have some of these the control plane components that run on the nodes, like written in Rust, where we could run it just with no operating system. But this is a pipe dream, and I don't even know fully where I would go with this. But those are components that I think could have advantages, for sure. Cbro, do you have opinions there? I'd love to hear that as well.
Oh, Cbro, did you drop a Go generics reference in here?
All right, rewrite kubelet and kubeproxy in Rust. IP tables to eBPF. Yeah.
Oh, nice.
Yeah, all of the IP table stuff. When we make jokes about that, what most people don't realize is, actually, do I have that in that? I think I have that in this video. So this is, actually, we walked through how the scheduler works. Where is CNI? All right, here's kubeproxy. So when you define a service and you set an IP address for it, that IP address doesn't actually exist anywhere. It doesn't exist. It's just a CIDR block that's dedicated to the services. And then what'll happen is the API server will then manage that, and all of the services that match this label will then become endpoints. So what the API server does is it looks at those endpoints, and then all of the agent nodes running kubeproxy will write IP tables rules. So now when anything else on that node tries to refer to this completely made up IP address, IP tables rules will kind of throw it at random actual routable addresses, which can make trying to debug Kubernetes networking issues an absolute nightmare. You're like, why does this pod not work only on when it's running on this node? I don't understand. Yeah.
It's IP tables all the way down.
Literally. But there's still a need for a container runtime. Yes, there's still a need for a container runtime, but I argue, what is a container?
Yeah.
Right.
We saw the WASM stuff before. That's an example.
A container is an executable thing in a zip file of its data. That could be firmware, right? That could be. We closed it. GitHub.com/DataSlabs. That could just be a WASM binary. We can run WASM on embedded systems, right? So give me that Rust container runtime on the edge. Exactly. We'd love to see tiny Kubernetes compatible runtime that uses gvisor run. Yeah. Okay, so beginner stuff. If you go to Docker's Getting Started page, that will link off to a Docker overview. This is probably... Why did that not copy? That's probably a good place to get started with Docker. And then the Kubernetes page. There's also Play with Docker if you want to mess around with it without setting up. But we can also run through some basic stuff here as well. If we have some people here who want to understand like how to get started with containers, what's a Docker file, how does all that stuff work, we can definitely walk through that. The question that got me thinking, since container, it's just jailed process, why not implement Kubernetes container runtime? What does other container runtimes like Docker do? So there actually are a number of other container runtimes that are implemented. that meet the CRI interface. And many people actually run clusters that do not use Docker. So we've reached a point, I think, where Docker is kind of a synonym to container now, where people refer to like all containers as Docker. So Docker is a tool that generates images and can fetch and execute those images, right? By extracting them and looking at the manifest file and stuff like that. But all of these are built on standards now. So you actually don't even need tools. You don't even need Docker to build your container. There are other tools for that as well. And so even as an example in this Crustlet thing here, what's the tool that it's using?
Is it WASI or
No, the one that generates the containers.
Oh, ooh. I don't think I ever knew.
Because it does generate a container. Why can't I think of the name of the project that it uses?
Is it WASM time?
No. That's the WebAssembly.
That's just a funny name. I don't know.
Yeah, hold on. Is it in here? That's WASC and WASI. No, it's not in here. I can't think of the tool now. I've literally run this tool and now I can't think of what it is. Hold on, let's go to the intro. All right, so this one's scheduling pods. So is it 2? Is it 2? One of these is bound to run it. Okay. So here's the registry. Oh. Okay, yeah. Where are you?
WASM-2-OCI was referenced.
Yeah, there we go. So there's like this project. So the containers are actually implementing also a spec, which is the OCI spec, and that is basically an agreed upon specification for what a container is and what's going to be in it. Well, not a container, a container image. So this project actually just takes a WASM binary and converts it into a OCI based image so that you can store it in a container registry and use any other container related tool to pull it and things like that. So Builda is another tool that you can use for doing container stuff. Podman, yep. So how is kube control pronounced? Kube control versus kubectl versus kube CTL. Yeah, so I used to be a kube CTL when everybody was saying kubectl. Now I call it kube control because Brian Grant, one of the creators of Kubernetes and the creator of the kube control tool, shamed everybody at KubeCon, so 2018 maybe, and told everybody it is pronounced kube control. And you missed one, El Tamaz. Chris Nova now calls it kubectl. There was some nice just floating around a while back that implemented. Oh, have you all seen it's called Kate's What Happens When or something like that? Yeah, What Happens When Kate's. If you want some serious internal stuff with Kubernetes, this is a really cool place to go. So it basically will walk through the entire lifetime of Kubernetes requests and like what happens when you run certain commands.
That's pretty cool.
Yeah, it's really, really cool.
Nice.
Okay, so did we catch up on our questions? Did we get a response from Nil on whether there was questions on beginner stuff? Was this just like a links to tutorials and things like this, or was this like a very specific like can you help me with building a container?
Yeah, I scrolled back. They said, what is the best advice for a beginner? And then I think you followed up and said, do you mean just general? And then they said yes. So yeah, I think it's just general.
Okay, yeah. So those are probably some good places to get started. Obviously creating a Docker file is really the first place to start. I'm happy to do like a quick intro to that as well. So you basically start with a base image which is just a zipped up, from the root directory, of say Ubuntu. Each one of these commands is going to be executed in there. So it's effectively a shell script for generating the directory that's going to get zipped up as your image. So each one of these things run, they are cached this way, and that's what's known as a layer. So everything that's in one of these stanzas here is going to be a single layer and the output image. So run commands execute something in the container. We have the ability to set a working directory. We can copy files from our local directory into the container. This we're just running some more stuff. And this is a multi-stage build, which is slightly different. So we probably should have looked at it from this point. And then at the end, this is telling the container runtime what command it's going to execute. Once it's extracted everything and set up all the C groups and namespaces, what command is it executing? And there's also entry point, which is slightly different. And this is actually really confusing for beginners. So the difference between entry point and command is this. If I run docker run -t, I don't know, let's call it switcher here, right? Because that's what this is. So this is the name of my container image, right? So if I run this, what happens? Well, in this case, this runs switcher. Perfect. Okay, well, if I run switcher -a, what happens here? Nothing. Switcher still gets called. Whereas if I make this entry point, now what happens is what effectively gets executed in the container is RTMP switcher -a. So all of the additional parameters are actually forwarded in as arguments to that. But I remember a lot of people getting confused by when to use command over entry point. How modular are the Kubernetes components? Would it be easy to switch out, say, etcd for some other distributed? So etcd is probably going to be the one that is the most tied in to Kubernetes.
You would have to change thousands of lines of code to get off of etcd.
However, I will say it's doable. If you wanted to do it, you would only have to rewrite the API server.
Yeah, that's a good point.
But because everything else, do I have a diagram in here? This has actually been pretty useful pulling up old slides. Okay, so we're a couple frames off. Everything else in the Kubernetes cluster, micro-K8s did it. Yeah, that's true. So everything else in the cluster communicates through the API server, including the control plane components. So that's sort of where all the brains are. So you could swap out the back end. And then again, like this talk is actually really useful if you're interested in that type of stuff, like how to customize things. This whole talk is me basically talking about doing that, like using Kubernetes as a framework for building distributed systems, what each control plane component does, how or why you would customize it. So like even here we talk about like the scheduler. Well, the scheduler is, it's complex in implementation, right? But as far as like how tied into the cluster it actually is not very tied in. The scheduler itself is just monitoring the API server saying, hey, I want to know about any pods or jobs that don't have a node name. And then while the bin packing algorithm is complex, right? The surface API for this is not. Its whole job is say, tell me about pods and jobs that don't have a node name assigned to them. I'm going to do whatever my algorithm is, and then I'm going to set the node name and then store it right back in the API server. And then the scheduler's job is done, right? So you could write your own. You totally could write your own. And in fact, you can tell each pod which scheduler to use so you can have multiple schedulers running in the cluster at the same time. And like, why would you even want to do that? So what if you had networking constraints, right? What if these two things for some reason can't run where the same top of rack switch is, right? You don't want to saturate these. Like your pods, whatever's running in them is very network bound. Well, the scheduler right now does not account for that, right? So maybe you have hard requirements in here that says, each one of these pods takes up, I don't know, 100 megs of network, right? But then you need to make sure that you only schedule so many of those where one 10 gig link is or something, right? Like that. That might be a good opportunity to write your own scheduler.
Yeah, and these are standardized APIs too. You can generate code for it and write your own whatever.
Yeah. And that's really the cool thing I love about the design of Kubernetes is one, the declarative API with just reconciliation loops, and two is kind of like how self-contained each of the control plane components are. Almost all of them are just monitoring the API server and then managing other resources, right? So even when we talk about like the controller manager, right? Like when I submit a replica set and I say I want 2 of these things running, well, the controller manager is just watching the API server, and it's like, oh, 2 of these are supposed to be running. I'm going to go search the labels and see how many pods, a different resource type, exist with those labels. Oh, there's only 1? Okay, I'm just going to generate another YAML definition, and I'm going to throw it right back at the API server to create it. Oh, wait, there's 3 of them running now. I'm going to delete one of them. And almost all of them are just managing other resources there. Here, let me catch up on chat here. Okay, that's the how modular. K to code. Yep, K3S. I didn't realize K3S was using SQLite.
Yeah, me neither.
How could you decide to add yet another node to your Kubernetes cluster instead of just adding more juice, memory, CPU to your already existing nodes? So there are tools to enroll new nodes to the cluster. That's actually fairly straightforward. You're just going to use kubeadm, right? If you're using a cloud provider, almost all of them have a means of just either command line or web user interface changing the number of nodes in your cluster. And then in addition to that, you can install, if you have your cloud controller and that has the correct service principals to communicate with your cloud provider, you can also install the cluster autoscaler. And what that'll do is it can look at the resources that are available in your cluster and then automatically add or remove nodes based on thresholds that you set.
There was a question like, how would you decide, or when would you decide to add a node rather than scaling a node up? For me, almost always I would add a node because I try to keep my apps, if this is a greenfield project, I try to keep my microservices small in terms of memory and CPU utilization. So it makes sense to take any stateless thing and scale it out to more nodes. That being said, though, there are other considerations you have to take. Cost is one of them. Maybe it's cheaper to scale up instead of out.
Yeah. And I would say that scaling up probably makes more sense as your average load changes, right? Because now you're talking about like what's the default state of my cluster, like what's the default resources that I have there. Scaling horizontally makes more sense when like your environment's really elastic and you don't know how many. But however, it also begs the question of kind of resiliency too, right? So you need some number of nodes in your cluster if you want to be resilient, because you basically need n+2, right? Oh, Rocker Boost saying it right here. But you want 2+ nodes. Oh, right. No. I'm saying n+2. So the number of nodes that you need for your cluster to stay up, plus a minimum of 2 nodes. And the reason for this is that you inevitably will have nodes down for maintenance, right? So let's assume that you need to take one out of rotation for maintenance. You still need the ability to lose a node unintentionally, right? So that's something to consider. But yeah, so resiliency guarantees and how many of an instance of an application you want running on the same node and things like that might actually determine how many nodes you need in your cluster. I guess that also brings up kind of the vertical pod autoscaler. So that's interesting. I have not had the opportunity to use that in production. However, it is interesting in the sense of a lot of people don't set their CPU and memory constraints on their containers, which bothers me. Because you don't know what to set those to, right? And it takes time to sit here and figure out what that is, and sometimes you're wrong. However, if you were here at the beginning of the stream, you heard the exact reason why you want to ensure those are set all of the time. And I gave an example of a nefarious thing I do to people at workshops, which is have people set up a replica set and then scale to some insane number of replicas, like 1,000, and then watch them take down their entire cluster. And the reason for this is the scheduler is awesome, but the scheduler can't help you if you don't give it some hints, right? So it's just like, looks at your pod and it's like, well, I don't know how much CPU and memory it needs. It'll probably be okay, and just gladly schedules it for you. So it's important to put those things there, because if you don't, then you end up saturating the node. The node can't communicate with the control plane. The control plane thinks the node's down, therefore reschedules all your stuff, takes down the next node, and it's really bad. So if VPA helps these things being set in clusters, I kind of like that. But then I also wonder, like, what's the reverse of that, right? How do I know when it's too much, right? Like, so it just gladly keeps going up, but maybe I want my application to die, right? Like, it's just leaking memory. So I guess I'd have to look at how that's implemented.
Don't let your apps go unbounded. That will but that will let you do vertical pod auto scaling more intelligently, and scaling out to horizontal too.
I've been lurking all stream, so I got to check out this VOD. You can't avoid Docker or Kubernetes these days. All good knowledge to have. Yeah. I mean, you're going to run into Docker and Kubernetes absolutely everywhere.
Rockerboo, can you overload resources with overlapping nodes? If you have a node that runs 20% utilization with some spikes, for instance, I want to have one CPU but want 2+ nodes. I think that just ties into the N+2 thing, right?
So VPA, basically what it does is, if you don't set on your pod how much CPU or memory that the pod requires, as its CPU usage climbs, it will update itself to change those restrictions to be higher and higher and higher.
Oh, yeah. Yeah, so the intent of it is to try and prevent overloading a node.
More soft school question. How much do you think the average developer needs to know about Kubernetes in order to write good apps to run on Kubernetes? So I tell people this, learning to write applications and designing distributed applications, right? Because that's what we're doing with Kubernetes. That is a completely different skill set than operating a Kubernetes cluster. So the important thing is assuming that you're using a managed cluster and or you have a team to support your Kubernetes cluster, you should really be focused on the skills of how to design secure and well-designed distributed systems that run in containers, and the service discovery bits and things like that you're going to be leveraging for building your distributed application. That should be the area you should focus on, and don't get too in the weeds about, how to install and configure a Kubernetes cluster and all of these things and secure them and things like that. Hopefully you have people who do that. And if you don't have people who can do that for you, or a managed provider, then you should really question whether, like you say, you have too small of a team to do that. You should really question whether now is the time to adopt Kubernetes, and maybe just containers is the right starting point. I would suggest taking a look at the CCAD curriculum. I actually haven't looked at that, so I can't make any real good recommendations about it.
CCAD is it's a pretty solid curriculum. It focuses a little bit, for my taste, it focuses a little bit too much on Kubernetes specifics. And I'm with you, Eric. Kubernetes tries pretty hard to have to allow you, the app developer, to not need to know a lot of Kubernetes specifics when you're writing the code for your app. You do need to know a lot about building distributed systems, but you don't need to know Kubernetes specifics. I did a talk, I'll shameless plug this talk. I did a talk, what is this, 2017, I think, at KubeCon. And it talks, I think it gives like 5 of the biggest things that you should keep in mind when you're writing an app to run on Kubernetes or some other distributed scheduler like it.
Okay.
Hope it helps.
So I think we're going to have some clarifications here. So Rocker Boo says, my use case is to run containers on a VM using Kubernetes, but it's only one CPU running really low CPU stuff. But I want the orchestration for running multiple containers. Can I just use Kubernetes on a one CPU node with multiple Nginx containers? So Rocker Boo, then what you're talking about is not actually orchestration. I would argue that you can just use Docker for that. Use Docker for that. Change your Docker host, locally to talk to that Docker, and then you can run all of those containers that way. When we talk about orchestration, what we mean is telling the cluster to find somewhere in the cluster for this to run, as well as like handling things like east to west traffic. How do these things communicate with each other? How do they find each other on the network? All the service discovery bits. It doesn't sound like your use case is using any of those things. You're just using containers for packaging and distribution. So I would argue, I think that Docker alone for you is all you need. You can just set your Docker host locally so that you can talk to that Docker instance instead of locally, and problem solved.
Make sure to run your containers with restart always on, so that you still get that, I'll keep it running feature that Kubernetes will give you out of the box, but Docker,
right,
you gotta configure it.
Yeah. So I wanted to learn Kubernetes, but it sounds like maybe I don't need it yet. You definitely don't need it yet. If you're trying to use this as a learning experience and it's just, you're a pet project, then, hey, why not? And maybe for that one node, just use like a microK8s or K3s or something, right?
It's actually, when I learned Kubernetes, I did it on one node because it was a little bit easier to just think about the Kubernetes basics, not yet needing to learn about all of the problems that come along with trying to get a kubelet to talk to a control plane API across a VNet in the cloud.
I also wanted the orchestration part, but for a bunch of tiny amps. But if you want all that monitoring things and so on, it ends up being expensive. Yeah. Minikube. Yep, Minikube is another option. All right. Regarding resources, a few days ago, my team and I experienced that one of our containers overstepped the max memory limit. We assigned the container using Kubernetes resource limit option. Limit was set to 2 gig, but Kubernetes Prometheus told us that the container used 3 to 5 gigs. How is this possible? Maybe we did something wrong. So all of the C groups, is the memory C group the same? I'm trying to remember. Cat sys fs C group mem. I guess we can just use it. I don't think I have any set here. No. C group clone children.
I've
does it set soft memory? Now I'm trying to
I
remember.
I don't know, but I have seen that with especially with Java apps
Yeah, so
for whatever
in
reason.
the way it's implemented for the CPU C group is it's the number of shares, which is really weird. So you're not actually telling it like, hey, you get, one fraction of a CPU. If you say you get 10 shares, well, the parent may say, I have 1,000 shares and it's going to be split up this way, right? But let's say the parent has 1,000 CPU shares and the child has 10. Well, there's nobody else for it to share. So it's perfectly capable that it could overstep and use all 1,000, right? It's basically, you're basically setting the CPU usage proportional to each other. However, you can kind of push over into others. I think network does too, because I think it's a soft quota. I'd have to look. I mean, we could run one and set memory constraints on it. Let's do it. Why not? So we're going to do docker bin bash. Is it dash mem? Is it mem?
Yeah, I think you have to put an uppercase G at the end or M or K.
Is it?
K,
All
whatever.
right, hold on. Docker. Gotta love. Been doing Docker for 6 years now, and I'm about to Google Docker run memory. There we go. Runtime options. Memory. Oh, it's memory equals that minus M. Okay. So I was like somewhere in between the right answer. So it's minus M, and we're gonna say, I don't know, 100 megs. All right. So here's our container, 6E something or another. So let's go look at what the C group has. 6E. All right. What did it set in limit in bytes? Memory dot limit in bytes. All right, so it did set it there. What did it set for soft? Yeah. So it's like all of the memory, right?
Yeah, your computer.
And then we can also, so this is kind of fun if you ever want to play around with like what's actually happening under the hood. Like Linux is actually doing all of the accounting, right? So we can see in this C group, I can see what the memory usage of that container is. So that's actually a really good question because it looks like it did set it there and not in the soft limit. So it might work. It may behave the same way as the CPU control groups, where it allows it to basically burst into available memory that's there, rather than like being a hard forced. Let's see. Oh yeah, K9S is like super cool. If you've not seen K9S, this is just really K9S. Like, how cool is this, right? Like, oh, I wanna see the logs for this. Boom. Well, really, I want to see the last, 30 minutes. I can escape to back out of here. We can port forward it. We can just hit S to get a shell into it. Well, apparently not that one because it's crashing on me. There we go. Now we have a shell into the kube proxy container. Like, yeah. We can just Control K to kill it. Yeah.
This saves so many keystrokes.
Oh, see, bro, you hadn't seen K9S yet? Yeah, K9S is awesome. I mean, also if you like cool tools like this, like LazyGit is another cool.
Yeah.
Is another cool tool if you haven't seen it. I like these like cool terminal UI applications to manage things.
It's cool because you still get your keyboard shortcuts, but you don't have to remember all the commands of all time. You just get it.
I just
kinda
made
in
a
front
whole
of you.
build deploy system in HashiCorp announce waypoint. they use containers mostly, so I'm just going to. Okay, so yeah, so this is Life Rocker Boo. Welcome to technology. I spent over a year building a distributed like orchestration system for a company that I worked at in Go. And then we were having problems with how to package and distribute Ruby apps because it worked for the Go stuff. And then containers came out and it was like, perfect. This will solve this problem. And then Kubernetes came out and it's like, well, great. I guess I'm deleting all this code. Because Kubernetes was like a way better thing. Although something did live on, SkyDNS lived on, right? Which was used for doing DNS-based service discovery in this thing we built in like 2011, 2012. That ended up living though. So at least one part of it lived on. It moved over and started doing DNS-based service discovery for Kubernetes. I haven't looked at Waypoint yet. Weavescope. What is Weavescope?
All of the new shiny toys. Detect. What is it?
You built a crappy container orchestrator before Kubernetes? Yeah, see, exactly. So, yeah, that is.
We at my last job, we built a PaaS with our own orchestrator. Then CoreOS Fleet came out, so we used Fleet. Then Fleet started slowing down on development and blah blah, and it was between Mesos and Kubernetes, and I wasn't there for the final decision, but I think it was kind of like a toss-up. So I'm glad that went towards Kubernetes.
Why hasn't Amazon bought Weaveworks? I'm actually really surprised that Weaveworks has not been acquired. I mean, because even before like Kubernetes, they were doing really interesting things for container orchestration, and same with CoreOS, right? Well, like obviously CoreOS has been acquired like twice, right? Like, but like I remember in the beginning, crap, what was the name of it? I can't remember the name of it. They had it was basically like the distributed system D, where you had the unit files and it would schedule those in places.
I think it was Fleet. There might have been something under Fleet though.
Yeah. So there was some really cool stuff that was going on in the early days of this stuff. But yeah, Weaveworks has always been doing stuff. That was actually Weave was one of the container networking things that almost everybody used in the beginning. The other company, I guess, has been doing interesting things that I haven't caught up with has Portworx been acquired? Flannel. That's it. Flannel. Yep. So Flannel was basically like it, rather than like, if you think about like a Kubernetes manifest where you're like, hey, cluster, run this pod definition for me. It was, hey, cluster, here's a systemd unit file that I want you to run. I want you to run it somewhere in the cluster.
Yeah, CoreOS was pretty ahead of its time.
Oh, yeah. So,
yeah.
Brian Kettleson and I worked for the startup that was their very first paying customer.
Oh, yeah?
Yeah.
That's cool.
It's like a no-name startup that I'm not even sure still... do they still live? I don't know. But we were doing like fraud detection and stuff. But yeah. Did we catch up on questions?
Just looking over here. How would you, in a hybrid environment, how would you bridge the on-premise apps with hosted K8s on AWS networking-wise? Does AWS have, they must have their basically their VPN product to go to tunnel on-prem up to their cloud. I think all the clouds have that by now.
Yeah, that's going to be the biggest thing is VNetting, right?
Yeah. Let's see. Amazon has that.
However, there are some issues here, right, too. So is the question like, how do you make a Kubernetes cluster where maybe you have like nodes in both places? Or is the question, how do I just get applications to be able to communicate with things that are running in my cluster and leveraging service discovery, right? So
That's a good point.
If the question is like, how do I build this distributed Kubernetes cluster? the answer is probably please don't. There's going to be some really interesting failure challenges that you're going to have with kind of if you have networking hiccups and the cluster thinks that the nodes are down, then it's going to end up rescheduling the work somewhere else, right? But then you also have the problem where your nodes locally may still be running. And so there's some kind of unique challenges there. And I say this knowing that we built a system like this at Comcast, but that was one of those, like, we have our own backbones, like, leave us alone. But yeah, so I would recommend against doing that, especially if you're going to try to separate out like etcd into those things. That's just going to be challenging. I would recommend running a local cluster if you want to do Kubernetes locally, a local cluster and one at your cloud provider, and then probably VPNing the two together and using ingress controllers to communicate across them.
So Kung Fu says getting applications, legacy applications, to communicate with services hosted remotely. Yeah, so I think if you've got applications not running in Kubernetes and you want them to communicate with something in Kubernetes in AWS, that's reasonable.
An ingress controller, right? Ingress controller to publicly expose some service that's load balancing to things inside of the cluster. And then in the event that that thing shouldn't be exposed to the public internet, then you should probably look at using a VNet to connect your local machines to your cloud infrastructure.
Is WireGuard a good option?
What is WireGuard?
It's the peer-to-peer VPN. That could be a good option.
Oh, yeah. Yeah, I suppose you could use that. Yeah. I mean, because at that point, this is just basic network security, right? How else would you secure communication between one thing and another, right? So you could do mutual TLS. You could still expose it to the public internet and do something like mutual TLS, maybe even mutual TLS combined with IP restrictions, things like that. I've played with Tailscale. I have not played with HashiCorp Boundary.
Yeah, me neither. Checking that out now. I use Tailscale to SSH into VMs at work that work says should not be exposed to the internet.
Oh, it was announced yesterday too. That would be why I have not used it or heard of it.
HashiCorp Boundary.
How much would you trust IP whitelisting in something like Traffic Nginx Ingress? Carl, I think that's why I would probably combine that with, I'm more of a fan, and this is, my opinion, I'm more a fan of mutual TLS than I am of IP whitelisting.
Yeah,
right.
Here.
Because if I manage to, let's say for some reason I was able to get information about your network architecture and how things run, and I decided to compromise some other more easily compromised system, I would be able to then have your IP address. Like, let's say I got some container running on the same node. Well, its public IP address when I talk to the internet is going to be the same IP. So now I have access. So I would personally combine that with TLS mutual authentication, because then that would mean I would need to get access to something that has the cert. Some other things are, I would also use network policies to determine which containers can communicate with the public internet, preferably almost none of them if possible. This is another thing for anybody who's still hanging out that had questions about security. When you put your image pull secrets in your cluster, for the love of everything that is holy, please do not put credentials in your cluster that have push access. Don't do it. The number of clusters I find that have this is insane, and it hurts my feelings. Because here's the thing, like, if you lock down your environment, you have really awesome security people and they lock down your environment and I just cannot get anything onto the cluster. Well, I know one way that I can get stuff on your cluster, right? I can just push to your image repository, your registry, and then pull it down that way. The other thing that I can do is just get stuff to run, or this is where we get really nefarious. Remember, containers are just tags. They're just tags locally. What if I replaced your container image with something that did something more nefarious, and it was named the same thing, and your cluster just happily ran these things and nobody knew?
Quinn said, yeah, NPM. Yep.
So
There's prior art here for that kind of exploit.
What if run CI runners in cluster? I mean, you could. I mean, obviously, you would want to use your pod security policies, network security policies, all of those things. I would not run your CI runners in your production cluster. Yeah. So what I'm referring to is more from CI containers affecting each other adversely, which is probably a more limited security concern that you probably don't have to be terribly worried about. You'd have to be worried about like a developer in your own environment doing something, or maybe somebody compromising your repository. So I would say all of the pod security, network security policies, all of that stuff in place on your CI system. But never run CI systems in your production cluster. Please keep those separate.
In anything development, if you have a development cluster, if you have, CI, if you do staging, like spend the extra money to stand up a 2-node or 1-node cluster, whatever you need to just get that work done without touching anything in your production cluster.
Any CNI engine that supports DNS names using Canal now, but can only use IP addresses for network policies, that is. Yeah, well, right now, they are managed separately, right? Like, so all of the container networking is all IP based, right? Like, how do I get an IP? How do I route these things? All of this stuff. DNS is provided by a separate service. So all of the containers basically point to kubeDNS, which does the resolving of DNS and returns back, an A record or an SRV record for the cluster IP that is part of the service definition. So if you needed DNS-based naming, you're going to do that based off the service anyway. So you could either hard code the cluster IP in the service, don't let the cluster assign it, right? You could use part of the CIDR block that's not. And so as part of all of the Kubernetes networking, you can set a CIDR block, but you can also set what portion of it that it's able to allocate IPs out of. So you could have, you could reduce the pool size so that you can ensure your statically assigned ones aren't given out. Then you could statically assign that in the service, and then you would know what it is. The other thing that you could do is sit between CNI, right? So you could, so we did a couple of these things too. So where's CNI? CNI. No. This is, okay. So this is CNI. Okay, so these plugins here, right? So one is the IP allocation module. That one you're not so concerned about. But so what you could do is you could create your own CNI plugin, and your CNI plugin, you would just name it whatever you want, and you would have your own binary that's named the same thing. And it's going to get executed every time a container gets created. And it's going to be given a bunch of JSON information about the container, and it's going to actually have some upstream information about the Kubernetes. So you could make your binary go out and grab the service associated with this thing and be able to figure out what the IP address is that you would need to do, and then make that call Canal or something, right? So you could inject yourself here. That would be a way to customize this for what you want.
And then Alphamez wants to use the CNI for network policy that invokes external servers like third-party web APIs. I don't know how you could do that with CNI just because that IP might change while a container is running.
Wait a second. So, I guess to clarify this question, we've got some other questions here too about sign tags and stuff.
Yeah, that one sounds cool.
Okay, I'm gonna have to remember to roll back there. So, is the question here, Eltamas, like you want to set policies for the pods on which external things they can communicate with? Because what you could do is use network security policies for that, right? You could just use a network security policy for that.
Yeah, I mean, service meshes do the same thing with network security policy under the hood.
Yeah, and if you needed to do something like really special, you could use an admission controller, a mutating webhook, so that you basically, your webhook gets called every time some container starts up. And then you can do other things like add network policy or modify that pod definition or things like that based on what it is. So that would be a way to customize it for your own environment. And then I think somebody asked about Docker support for cgroup 2. I actually don't know. I guess we would have to ask somebody at Docker. Yeah, sign tags would be cool. So cryptographically signing things is like one of the reasons why I like WASC too, right? Or it's each set of, exposed APIs, syscalls essentially to WASM have to be signed, and they can be signed by different keys, which is awesome, which makes like some team responsible for which apps are able to leverage this functionality, and not like, oh, well, by default, unless you've locked down this host, you get access to everything. I really love the idea of kind of like inverting security, right? Where like by default, you get access to nothing unless you're given it. And even then, there's no ways of getting around having somebody with keys to do that, where we cryptographically sign some cert that says you get access to this. Exactly. Trust nobody, especially Rockerboo.
Yep. Zero trust. Only when it's Rockerboo. Everybody else gets trusted.
Did we catch up on questions? Are we caught up?
Oh, King Fu had a good point. I think you were talking about MTLS. You want short-lived certs. Vault is a good option to manage this. I completely agree. And Vault actually is... Vault does the best job at rolling certs and just generally rolling credentials that I've seen. That API is a very simple and easy to understand.
Yeah. Yeah. Checking. I think we're caught up on questions. How did we end up caught up on questions?
Yeah.
I'm shocked. I'm shocked.
Who's got more stuff for us?
I've seen a bunch of follows too while we were in the middle of stuff. Thank you so much, everybody, for the follows. Also, don't forget to follow Aaron as well. He also has a stream here and talks about cloud native stuff. We probably could like broadcast this to 2 streams too. That would have been interesting.
That's why we need your switcher. Aaron.
What is your favorite soup? I don't know. Maybe basic chicken noodle. Although like a good tomato bisque with a grilled cheese sandwich, especially if it has like pepper jack in it, that would be really good.
I'm going lobster bisque. I love that. The heavy, terrible for your health. I love it. Going to try to containerize OBS. Any tips? No.
Going to containerize OBS headless. Don't.
Yeah.
I mean, you probably could. I mean, let's be real. I think you probably could. However, I will ask you, what is your use case for containerizing OBS? Because this project that we're looking at the Docker file for might actually be what you're looking for once it gets further along.
Let's see. You could NDI to your OBS in the container, and control OBS with the webhook plugin to do things.
Yeah, I guess I don't have a lot of good docs here, but what I've been working on stream the past month or so has actually been an RTMP switcher to play videos and switch between inputs and stuff like that, and do picture-in-picture and all of that stuff, and all signaled through HTTP. So if you're running headless OBS, that's probably kind of what you're probably trying to do, is a similar thing to me. Let's say someone wants to learn Golang. Do you have any open source project recommendations? Well, I guess the first thing I would do is probably the tour that's on the Go webpage. The other one is go.dev. There is a whole getting started section that links to all kinds of different ways of learning and playing with Go. Those are probably all really good places to start. There's also Exercism.io exercises. That's probably a good way. Where can I find more about MTLS?
Let me shameless plug that. Me and another one of our coworkers, Jennifer, we do a Monday stream at 11 a.m. Pacific doing Exercism.io Go exercises. So check it out if you're into it.
How does one go about adapting a simple OS written in, say, Rust as a base for Docker container? Yeah, so you can create your own images, right? So the from scratch container is a special thing that basically says that there's nothing else in here. Scratcher. What am I talking about? So this would be what you would start from, and then would be how you put your custom stuff in there. Your own operating system would be slightly different, though. Like if you're talking about you wrote your own kernel, then this would be different, because remember, a container is leveraging the host's kernel. So, however, if you wanted just a container that just only had your small binary in it, your static binary that has no dependencies on anything, you would use the Scratch container for that, which is ultimately what I'm hoping to do here later. This is the starting point. Later, we want to just copy everything over from here and make it as small as possible. So the real idea is web page to RTMP. So Cbro, we're same thought process here. This is exactly what I'm trying to build. This is what I've been working on building on stream. Why are you so shifted over there? Weird. I don't know. So yeah, this is what I've been building on stream. And so the next step, once all of this stuff is working, is to introduce WebRTC here as an input. Right now we can do videos and we can do RTMP. WebRTC is coming soon. But yeah, all of this is controlled through a scheduler over HTTP to switch between individual streamers, to add outputs, add inputs, fail over to video. That's what I'm building on stream. In Rust, though. OBS to OBS, so you can do experimental things. Okay, if you need a secret token in the liveness or readiness probe HTTP request, how would you configure this in your deployment YAML file? I don't want to hardcode a secret token directly into YAML, but maybe use... Yeah, so I would manage it the same way as your other secrets, using Vault or something like that.
Are you, Eltimaz, are you saying that in order to call a liveness probe, you need to pass a secret to your app from the kubelet?
The other thing you can do is you could run an init container, which fetches the secret and then stores it into the whatever place it's needed for the probe. Because at the end of the day, the probe is just code that's running inside the container.
Yeah, but you have to specify it in the YAML file, in your YAML for your pod spec. So I don't know how you would pass in credentials from the YAML.
I guess I'll just answer it here. So Zebra asks, okay, that's cool. How are you going to get OBS Ninja sources in there? Yeah, so same thing. There's going to be lots of stuff like automatic lower thirds, so that when you push a video, you can just add that. And all of that will be done through a browser source. So we'll try to get Chromium embedded framework to run inside of here as well. Yeah, we definitely should collaborate. Right now, it is just me working on building this thing. So it's not moving as quickly as I would like. Use VirtualX frame buffer and FFmpeg to capture that. Or read my book, go in action. Is the bot broken right now?
I don't know. A book is a command, right?
Yeah. Maybe I don't have... Wait, no, because didn't Dr. Dumenberg set things to pink?
Yeah.
This is gonna fail. No. Okay, the bot has not been running this whole time. Automatic captions. So automatic captions is also on the issue list of things to figure out. The other thing that's on the issue list of things to figure out is I want to measure bit rate so that if a live streamer falls off, I can fall over to another input or even to a video and seek to the position in the video where they were in their talk. So yep.
That's a paid feature. I'm just kidding.
Yeah, and
cool.
I think I talked about picture-in-picture.
We had one from Carl Vandergeest asking, where can I find out more about MTLS? Are there any specific projects or products? For MTLS, I don't know if there's a specific place. I know that it's used a lot in Kubernetes itself. So if you look at the kubectl source code, if that's how you want to learn it, all of the auth stuff is in a specific package inside of that code base. And most of it is all around doing just that. Getting the cert public key, getting the private key for the client cert, figuring out how to reconcile them.
Did you link to that project?
I will link to it. And I'm sure there's a guide on MTLS somewhere. I'm just not familiar with it.
Okay. But would need Kubernetes to do its stuff when checking for readiness liveness. If it is a child process in the container, I don't know how to pass those details to Kubernetes. Yeah, you would end up where you would need... You would end up where you would have to do one of two things. So number one would be the secret would have to be exposed to that container. Right? Yes. Or the other option would be that the thing that you run could go out to Vault and fetch a whatever key it needs. That could be another option. I'd actually be really curious what the use case is there where the liveness or readiness probe needs a key. Oh, because of like something like mutual TLS.
One thing that might work is put a second container in. Put a separate pod spec into your pod. So 2 containers in the pod, and point the readiness liveness probe to the container you just added, and have that container access the secret, have that container forward the request onto the endpoint, whatever endpoint you want in the original container.
I think I caught where you were going with that.
Yeah, I probably didn't explain it very well.
Can you recommend some cheap PC that can run Warzone at like 100 frames per second?
Let's see. You
Cheap?
could build
No.
one. You
Cheap.
could, yeah,
And what is your definition of cheap?
under 22,000.
Like, where can I get $100? Where can I get $100 machine that runs it?
$600.
Yeah,
I don't know.
I mean, can the 3090 even do 100 frames per second? I mean, and there's $1,200 right there just for your GPU, right?
Yeah, good question.
I don't even know whether that can do 100 frames per second. Well, we have third-party application that have health endpoint that we need to use for readiness liveness probe. The health endpoint needs an API token, otherwise requests will be rejected.
Yeah, I would go with a second container that has an open endpoint for readiness liveness, and that container is the thing that gets the API token, forwards the liveness check on to.
Yeah. So if, effectively, you have a sidecar. I mean, but then you end up having this exposed thing. So
Well, if you run it
so
on a separate port, then it's only exposed in the inside
actually,
the pipe.
don't do a port binding. Have a binary or shell script or whatever inside the separate container that gets whatever certificate or holds whatever certificate, right? So you could use Vault or something like that to mount in the secret, or you could use an API to fetch it, or you could use the init container to do it. There's a variety of ways of getting the secret into that container, but have that container be the thing that hits your actual API endpoint with the certificate.
Much better idea. Yeah.
And then the health check will just call that shell script or binary in the container that is its only use cases for doing the health check and nothing more. So you basically keep your credentials and how you access your credentials in that container. Is RISC-V the future? I hope so. GTX 1660 good. I don't think a 1660 is going to do 100 frames per second. With regard to RISC-V, JBSD on RISC-V is super neat. If you want to read up on RISC for securing computing hardware level capability management. Yeah, I need to do more research into RISC-V. FreeBSD jails in hardware. So that's interesting too. Like, I need to read up a little more on that Musin too. Like, how does that compare to, like all the secure enclave stuff with Intel and things like that? But the question is, Aaron, does your 1660 do 100 frames per second?
I've not pushed it that often to 100 frames per second, but I'm guessing. I'm guessing it'd have a tough time.
I'm willing to bet it does not do 100 frames per second.
Yeah. But I am pretty happy with it overall. I mean,
I've got a 2080 in here, but I'm itching to buy a 3090, and I really don't need it.
I didn't even need the 1660.
Did we catch up on questions?
Yeah, I think so. I'm just scrolling back. I don't see.
Nice. Yeah, I think we caught up again. Look at that. We're staying on top of things.
Yeah, that's the second time we caught up. Yes.
And this is a lot of questions, and this doesn't even include the ones that we've been answering. I have been putting them in here because we've been caught up. When did you start containers, Aaron? When did you get in that space?
It was 2 jobs ago. Actually, no, it was. So I worked at a company that tried to do a mobile backend as a service, which failed. Basically, like AWS Amplify or Firebase. It tried to do that. We ran. This was in 2012, I think, maybe 2011 or something. So we ran like a custom code backend, and we tried to quote sandbox JVMs so people could run Java code. That was when we started. That was the first time I did containers. So I tried to move that over to a separate container on a specific node dedicated to each user. That was the first use of containers that I ever touched. So I think that was 2012, I want to say 2011 maybe.
So this
And
was pre Docker, right? Yeah.
And we used Solaris zones for a bunch of stuff because we were on Joyent. So Solaris zones was pretty interesting. But then we moved over to Ubuntu and used LXC.
Okay, so what do you dislike the most in regards to Kubernetes? I can take this one first if you want.
Yeah, go ahead.
We'll fire some shots here. Let's see. I would say one is the management of all of the YAML files, which isn't too different from infrastructure as code anyway, because it's all infrastructure as YAML or infrastructure as JSON, or I really look forward to a day where we have a different way of communicating with these systems. The other one I would say is just a lack of tools to debug. There's a lot of places to check for things, and how do you correlate the data, and this is really a distributed systems problem in general, right? But when things aren't behaving correctly with my application, is it an application problem? Is it a node problem? Is it a cluster problem? You kind of need to know. It becomes a very leaky abstraction. So the third thing I will say that builds on that is it's not as big of a deal that the tooling and all of that stuff doesn't exist. The even bigger deal is that none of the tooling exists, and finding that knowledge is really tribal, right? So people who have gained this knowledge through a long time of suffering in production, and it's just in their head. There is a ton of how to get started with containers, how to get started with Kubernetes content. There's almost no content, and when crap goes wrong, how do I even begin to start figuring out where the problem is? So there's not a lot of day two content or tooling for this stuff. That's probably my biggest thing. And the fact that it's moving so fast and people are adopting it, like new service mesh comes out today, tomorrow it's in prod, Yeah.
But that example, the tribal knowledge thing, kind of happened here with K9S. I don't remember who asked, like someone said, "Oh, I hadn't seen K9S."
It was Cbro, yeah.
That's Cbro, yeah. For me, I'll go to the code itself. I agree with the day two thing. I certainly agree with the day two thing. But yeah, the code grew so. This is kind of like in many fast-moving projects, but in Kubernetes, it's a little bit unique because it's the biggest Go code base in open source, and it grew in lots of different directions, written by lots of different people with various experience levels, and you see some big anti-patterns. The anti-pattern that I really dislike the most is that you have to import certain packages that will register global state for you. So you have to do, import _ the package in order to get global state registered, in order for you to register and use a new resource, a new Kubernetes resource. So that's a big pet peeve of mine.
So I know Cbro here has also had a long history in Kubernetes as well. I'd be interested if you have a one that we missed, a hate about Kubernetes. Yeah, everything is not perfect, right? Like we have to be remember like Kubernetes for the functionality that it serves. If you are running a Kubernetes cluster in your production environment, it is the least tried and true like thing in your whole environment, right? Like we are usually not quick to do that, right? Like you're not. If some new hardware requirement comes out, some new piece of hardware comes out tomorrow, are you sliding it in your rack? Probably not, right? Like even same thing. Like if I invented a new security device today, would you put it in production? Like so we have to remember it's still young. It's very young and it's moving very fast. And when things are young, we haven't exercised every aspect of it, right? There's going to be weird bugs. There's going to be security things, right? Then tie that into the fact that it's also moving very, very fast. So that can make things a little more brittle and things like that. Fortunately, the whole system is hopefully designed around resiliency, but it's just things to consider, right? Like things are going to change, APIs are going to break. Look at the way like container runtime stuff has changed since Kubernetes adoption. Like all of these things, like now we're pulling out storage, and first we pulled out networking, and it's evolving very, very fast. And this is why I also recommend if you're going to run your own cluster, you need a team. Even with this as your full-time job, you can't keep up with all of the changes that are taking place, which means that makes debugging your cluster and stuff like that extremely difficult because you're trying to debug something that's just evolving like crazy. Nothing I really hate, as I said before. I think it's a great platform. Yeah, absolutely. I think it's a great way for everybody to work together on creating an abstraction rather than everybody creating their own abstraction, right? So Kubernetes is almost a PaaS, right? Except now we have lots of awesome providers all contributing to making one awesome, and we can all benefit from just talking to this one API and not be constantly designing systems around all of the individual ones that exist. Let's see.
Like a PPaaS, like a platform as a
Yeah.
service. I agree with, collaborating on building a new platform, as we're moving up from IaaS now into here's the API for your IaaS, and it's one API to rule them all.
Another thing that annoys me is generally about the ecosystem is that everyone wants me to install their CLI, Helm, EKS, CTL, just so many things. Argo CD. EKS has its own CTL? Really?
Why?
Yeah, but why?
To shell out to kubectl.
Yeah, so that's just a terrible experience, right?
Oh, it isn't made.
Oh, it's Weaveworks. Okay, I was gonna say because like with Azure's AKS thing, right? Like I have like AZ AKS list, right? So
Oh, this is actually interesting. It's for administering an EKS cluster. It takes in a cluster config resource.
So like I have access here, like so I can talk to Azure, like tell me about all my AKS clusters, but like I just do like an AKS get credentials, right? And I would just pass it the name of my cluster and resource group, right? And then it just stores my kube config for my cluster, and then I just use kube control for everything else. Like I guess I would have assumed that everybody worked that way. Finitely generated. Thanks so much for the sub. Okay, this is all the stuff you were saying is made by other thing. Yeah, there's a bunch of different tools that everybody's installing now, and I used to have all of them too. I used to have like Builda and like all of these things, and now I'm becoming a minimalist in my container stuff. Just Docker and Kubernetes and K9S and kube control and AZ.
Yeah.
Okay, maybe not so minimal. A medium level minimalist.
Well, that's like that's about as small as you can get, isn't it?
Yeah. I mean, well, I guess like if I could get rid of the AZ command if I only used the portal, but like I'm more of I would much rather use the CLI for that stuff.
Yeah. Yeah, lazy Docker is pretty sweet.
Wait, there's a lazy Docker too?
Yeah.
All right. Is it in Pac-Man? Lazy Docker. Are you in here? No. All right. Is it in AUR? Lazy Docker.
Let's see.
Okay, here it is. All right.
Yeah.
Yep, we're gonna install it. Yeah, yay. Lazy Docker. Now I want to see this. Is Kubernetes HC Enterprise ready? I'm not sure what you mean there. Wait, was that really trying to install Go?
Really?
I have Go on here. And
It's installing 1.15.
and why wait a second.
Needs Jack.
Why does wait. I don't know whether I trust this anymore. Why does a Docker CLI tool need audio stuff?
Linux Brew installed the binary, so I don't know what happened over there.
Yeah, like what is yeah, all right. I'm going to take your word on it, but I'm not installing lazy Docker. I can't for the life of me understand why it would need Jack.
Speech to Docker. I like music.
Oh. It's something else.
Just that you're updating.
Okay. Whew. It's like, all right, well. I did SYU out of habit. I've been getting away from all the YAML files. What do you think is the way forward? I don't know. I really don't know. Like Metaparticle was an interesting thought exercise too.
Real-time audio capture.
Is it in GitHub anymore? I guess we can pull up old doc for here. So Brendan Burns did a whole talk about Metaparticle here. And so it's really interesting because he starts kind of like, what if, in code we define like, well, this is my service and it needs to be exposed, or where's a good example of sharding? Yeah, so you create a sharding function and things like this. So it was like this whole idea of like it's actually in the code. And then when you compiled this code, it would actually generate all of the bits that Kubernetes needed to run multiple instances of this, put a service in front of it to load balance. But that service also was aware of how to do the sharding, so it knows where to send all of the stuff. And it would know how to containerize the app and deploy it. And so I guess we could link to this here. I'll link to this if you want to see it. So this is like a really, really, forward thinking thing. And like, is this the answer? I have no idea, right? Maybe, maybe not. But I like the thought process of like, what does an environment look like where we're not messing with the YAML? And I think that that's kind of a cool. I freaking hate Kate so far, and the reason for this is that my boss got a Kubernetes cluster and told his team from one day to another that they needed to migrate all of the company apps from a classic Windows Linux environment to this new Kate's thing. This is 2 weeks ago, and everything is a mess at the moment. Everything from security to networking, because my boss just wants everything online and doesn't care about the detail. Yeah, that sounds like just a really poor kind of design and planning. Like, this stuff should be thought out. People should have been able to test stuff. They should have been able to experiment like with what struggles they were going to have with getting specific. Like, this really should have been like an R&D effort that a team should have like went through first.
Yeah.
So you can do RT audio capture in a container. Mm-hmm. So why do I hate Kubernetes and not only my boss? When being forced in this way, you get annoyed, and when there's no day 2 guides. Yep. So the problem with configuring with code is that it makes static analysis difficult without running a program. Yeah. Yeah, and that's sort of the thing why I say, like, is that the answer? I don't know, probably not, right? But I do like the idea of, like, how do we how do we how do we get past the YAML, and just, I like the idea of thinking about, like, what does it look like when we get past that? What are the other ways we could interact with it? And, like, maybe metaparticle isn't the thing, but maybe it's the thing that triggers some idea in somebody else, right? And I think that that's really, really cool. And actually, if anybody here has seen the show *Halt and Catch Fire*, in that talk we've been stealing slides from all day, I actually, in the very, very beginning, steal a line from it. In the first episode, they say computers aren't the thing, they're the thing that gets us to the thing. And I stole that. And, Kubernetes isn't the thing, it's the thing that gets us to the thing, right? Because we don't really talk about computers that much anymore. We talk about all of the stuff that they facilitated and exposed to us, and we can now do, right? So that'll eventually be what Kubernetes is. It's, so far kind of down below, we just don't think about things. It's just something that we have that allows us to do all of the other stuff. Ballerina is actually really cool too. I looked into that a little bit early on. It's basically like a cloud language, right? Yeah. Kind of with that baked in. And I looked at it. I didn't like that it was built on the JVM to begin with. However, I don't know where they are at with it, but I know that there was an effort to get it running on LLVM, which makes it even more enticing.
Yeah. They were gonna do with the LLVM effort. They were gonna do self-deploying containers as the underlying implementation. I don't know exactly what they meant by that, but it sounded cool. It sounded like they were gonna go with a single binary self-contained with the runtime. Just go.
Interesting. I have dark reader on, but apparently Docker, like, interesting. So Quinquan said, what is metaparticle? That's sort of that thing I was pulling up the slides from, and I linked that video. It's basically like creating a library in your code where you sort of write code to define that this is a service and it needs to be sharded and all of those things. And then the compiler kind of executes. The compiler builds the program, and then when it runs, it's able to kind of like containerize itself and deploy itself and all of that. It's this really wild idea, right? And there's a lot of interesting problems that creates, right? But I do like the idea of watching people do these crazy wild experiments, because if that's not the direction we go, that's going to give somebody else some crazy idea, which is going to give somebody else some crazy idea that's eventually going to be the thing that we use, right?
Yeah, and we get to focus in more about what is the goal, and obviously we need to figure out how to implement that.
Yeah, I don't want to manage YAML files for the rest of my life. Somebody please smarter than me fix it.
Yeah. I want easy, fast, and correct. And I want to pick 3.
All right, what other questions do we have? It's kind of interesting because this is like turning into like a distributed systems conversation too, which is also interesting. I just like point and click since we need the config and code format in order to properly check into. Yeah, and so I'm torn about this, right? Like, I personally don't like UIs, right? Like, you are literally staring at like the most minimal setup ever, right? Like, I'm using i3 window manager here. I mostly keep a couple of terminals open and, a web browser, and like that's it. I use mostly command line utilities for things. So I'm not much of a point and click person, but I do recognize that there is a community of people who are solely point and click developers, right? There are, a lot of people who just use like Visual Studio, and that's like you do everything from Visual Studio, like including deployment. There's a significant amount of people who will do things in the portals for Azure and Amazon and Google and all of those places. So, I have to force myself sometimes to go through the process of doing things in the GUI apps or portals sometimes just to so that I can have legitimate conversations with people, right? Because then I can't tell you how to do something when I'm like, I've never used the portal. What stack do you use for web development? So I personally am a Go person. I've been doing Go since 2011. So that's my default is using Go for the HTTP API server layer. And then it used to be React for the front end, but more recently I have been enjoying Svelte. I don't do a ton of web development though, so GUI can drive config as code too. It's just a presentation layer. Exactly, yeah.
Yeah, I know I only know about the Azure GUI, but I know when you deploy something, it gives you the option to export the ARM template, it's just their proprietary version of the declarative API, and then you can save that and redo the exact same deploy using that JSON they spit out.
Yeah, Cbro brings up a valid point here too. Web GUI is needed in a lot of cases where some people don't have access to CLI because of policies. This is actually very true. There are engineers that don't have access to CLI tools. You know, it's kind of interesting how different policies can be at different places, right? Like I've worked on systems where you could only use machines that they gave you. Everything was locked down, all of that stuff, and then now I work in an environment where I have a company issued laptop in a drawer over here that I probably have not pulled out in at least a year and a half. Like updates haven't even been run on it because I haven't even opened it. The battery could just be dead from like never being charged. I don't even know anymore. This is my own tower that we're working off now, and this is where I do all of my development.
Well, I'm gonna have to go soon because I got to work on the talk.
As of this week, I'm not allowed to use my personal computer to access my corp email. Yeah, so I do have a personal laptop here that has my corp email on it, but it is enrolled in Microsoft's network stuff. However, it's minimal what they do though. It basically sets up certs, checks that antivirus is running. Like it doesn't like take over network or log what's going on or anything like that. Oh, and the ability for it to delete like my Outlook profile or something like that in the event I quit. But yeah, that's all that they do.
They set up the VPN, right?
Oh, you don't have any enrollment for personal laptops and desktops? Yeah. Yeah, and it probably installs a VPN too, yeah. But the VPN isn't even on all the time. And even when you are on the VPN, it doesn't route everything through there. Yep. Like some companies I've worked for in the past. Comcast.
I was in the same boat as you, see, bro. I worked at PayPal back in the day, and you couldn't even, they had like the SSO for GitHub. You couldn't even access their public repositories if you were logged in and not on a corp computer or whatever. Corp laptop. That's the word I'm looking for.
Yeah, I always make the joke about that whole like lockdown thing for Comcast just because it irritated me. And it wasn't even about like the privacy concerns. It was like I had a really good internet connection at home, like really good. And like to listen to Spotify, it had to route through their network. And like, why? Why does all of it have to go there? So like any good engineer, what you do is, I was running Linux on the desktop here. What you do is you download the source code to the VPN client, and you don't let it set up routes for you. And you have it set up just the routes you want it to. And oh yeah, all of that stuff that comes over the VPN connection where the VPN server is like, I also need you to install this on the host. We're going to go ahead and comment that out too.
So you just turned it off.
Exactly.
You built a dev null.
Yeah, it aggravated me. It didn't take very long before I'm like, screw this. I am tired of Spotify cutting out when I have a solid network connection.
It's also ironic that the VPN went through Comcast and you had a slow internet connection.
Yeah, because you're talking about their corp network for their users. Yeah, like, no, thank you. All right, so you said you had to go. So, and I think we ran out of questions. So should we find somebody to raid? Who do we want to raid?
Who's on?
I think I saw a large data bank on, who is a Go developer.
Yeah.
Working on CockroachDB, or Anthony Writes Code is always a good one. Oh wait.
Oh, he's doing Docker
Anthony
stuff.
Writes Code is working on Docker. I think it is. I think it is determined. We must read Anthony Writes Code.
It is decided.
What database do you use? I haven't in a while. But MariaDB, Postgres, Cassandra, Redis, Memcached. Those are probably the ones that I by default will go to for one reason or another.
For me, if it's relational, Postgres. I've been Spanner. I've been checking out CockroachDB a lot over the past year.
I have used Cockroach in the past.
Yeah. But yeah, for me, if I can get away with it, I go with Redis.
Okay, so we should, being that we are not rating Large Data Bank, Large Data Bank here is also a streamer on Twitch doing Goat stuff. He is an engineer on the CockroachDB team and streams working on it. Oops, I typoed that. Large Data Bank. I'm like, I always mess up their Twitch handle. Okay, there we go.
Yeah, a lot of underscores.
All right. Also, I saw lots of follows here. If you are not following Aaron, who is here with us right now, where's my bot? Did the bot crash? It's just laggy. Weird. Maybe it's just Twitch's API. So definitely give Aaron a follow. He also does lots of stuff on Cloud Native when he streams. Right now, working on a talk for Python to Go, right?
Yeah, I'm going to stream it probably after I get some lunch.
Awesome. Well, maybe I'll jump in too. I'll get something to eat and then come show up. So, all right, everybody, let's all get ready to give Anthony Writes Code some love. Thanks, everybody, for hanging out. I may stream this weekend, but I typically stream Monday, Wednesday, Thursday from roughly 12:30 to 4:30 Eastern time. And then occasionally I'll throw in a Tuesday or Friday or weekend. Thanks for hanging out.
See you, everybody.